So, welcome to the second day of JIPipe Spring Course. Now we actually start with JIPipe. And then first, what is even JIPipe? As the start, JIPipe is an open source image analysis software. And the intention is to provide an easy to use graphical interface for you with that you can make your own image analysis pipelines easily. It internally has some plugin system, but it doesn't matter. It integrates and is based around ImageJ. So the idea is that when you have a workflow that you figured out in ImageJ, you can easily translate it into JIPipe and then have all the benefits of an automated workflow engine for you. And to achieve this, the tool is a visual programming language. This means it instead of you writing code like in ImageJ macros or in Python, you would use you would design then a flowchart using boxes that you connect in the correct order that you need. It is designed for batch processing from the get-go, so you can easily make your own batch processing macros or translate something that is for single images into batch processing extended. Although currently the version that you have has a bit of memory constraints, this will be then solved whenever I'm done with the actual 6.0 version. And the whole thing about batch processing is a zero-cost scalability, where you have your existing pipeline. You can add one or few things into it and or two things into it, and then it's scaling to be a batch processing workflow. So as promised, you get a tutorial on how to actually correctly install it, because over the years I've experienced different issues regarding that. So I will show you how to do the correct one. So you go into your browser of choice, and then on jipipe.org you can find the big download button. But this is not the one that we need, because this is JIPipe 5.3, which is, and you see that when it was released, it's like a year old. And we now have a year of improvements, but it's not ready to be released fully and say it's a fully stable finished version. There are some features missing in the 6.0, which is the next upcoming version. So if we instead go with download latest preview, which will download for you the latest 6.0 snapshot, and it's stable enough, we tested very well, and you can actually use it for production cases, but it's just not all features are there yet for that one. There are some yet to be merged in, basically, and but it's good enough in this current form. And then you have the option for your operating system. For Windows, just go with the exe installer. I don't know if we have it here. I just downloaded it myself. You can also do a portable package. Both don't need administrator rights. The exe installer will install it into a directory in your user folder somewhere. And the portable package you just extract, like with ImageJ. And let me first check, yes. And the Linux packages, you probably don't use Linux anyway, are the same. And for macOS apps, you just extract it and then you can double click it. Although macOS will complain about it not being signed. We won't do this, we won't pay hundreds of euros per month to Apple to just sign it. I'm gonna download this one as well. It's the official Microsoft download. From their side. I don't know why it doesn't come with Windows 11, but it doesn't. And sometimes you have to expect a few delays. For example, virus scanners will scan first everything for you. Currently we have no special virus scanner like Asset or Kaspersky, so it will be quite fast. But if your PC comes with an elaborate virus scanner, they will scan it first. So then when you have the setup, it's like with any Windows application, you just start it. It might then complain. We'll see it. Where is it? So it will complain that it doesn't know and it has protected it because, like with Apple, we do not want to pay a few €100 per month to Microsoft to sign the software. So we don't. And you just click show details and run it anyway. And then it will take some time. You have to be patient with the setup because it is literally 1 gigabyte of size. It's basically an ImageJ that comes with ImageJ and everything that JIPipe needs. And this is why I discourage installing JIPipe as an ImageJ plugin, because you need to install very specific things together with ImageJ. Otherwise, it won't work. Now it's waiting because the wireless scanner is scanning it. I put up the wireless again while it's whatever doing. Then we go next and then agree. Yes, it will make a test up icon for both Figge and JIPipe. So if it always comes with a Figge that you can use as a standard Figge, just don't update it. So then we're done. And let me see if it starts, even because sometimes it does not start, and then you have to install the other thing from Microsoft. It's just something that Windows 11 does not come with for whatever reason. It's a Microsoft standard library, and you don't get a notice when it doesn't work. And check in the task manager if it starts. And sometimes then it takes forever, but then when you look in the task manager, you see it's active. This is basically your virus scanner scanning it and holding it up until it thinks it's safe. And I will wait until everyone has it, because you have to set up the author information together. Switch to the presentation. No, there's not yet anything. So if it doesn't work from the start and it just doesn't start, so you might have to check in the start task manager. This is coming from ImageJ, not from JIPipe. All modern ImageJ will use this too. You have to install this C++ runtime as well. This is the same when you download Figge new now from figge.sc, then you will have to do the same thing. Download this Visual C++ runtime. I have to update this at some point. So if you like a dark theme or something, when it's already started, you can go into this customization tool and then, for example, set a high contrast theme where you can see better. Some colleagues use that as well, or a dark theme where everything is dark. Some people like that, not me for working at least. It's like here in Customize JIPipe. You can choose, for example, a high contrast theme. And then you have to restart it because it has to reload the theme. But or if it's super small and you cannot see, you can increase the scale there too, of like 200, for example, so you can see it better. But this is full HD screen, so it's fine. So and then what it will do, so if I hear some people probably finished already and some are stuck, there's this pop-up that will complain about author information. You can click it away, but it's recommended you set it up, because then the pipeline that you save will contain information that it's you who made it. You can, when you clicked it away, you can click here also this unknown author, and it will then pop up the configuration for it. And then you can just add yourself into the author list. So I'm adding here both Sultan and me into it. So I click add, and then configure it, edit, and then first add Sultan. And then you can also put an ORCID if you have an ORCID, but I don't want to look it up. And then affiliations, you have here the admin guy. Okay, this will complain, but it's fine. And I'm gonna add myself too. Just fill out the form with as much information as you can. This is then tracked internally inside the project automatically when you edit a project that someone else was working on, it will automatically add yourself as an author, so it's properly tracked who contributed. So this is just quite straightforward, filling yourself, and then it will update itself below to an author information. Does everyone have north, south? South? This must be east. The Windows will usually block the installer, but you have to then click run it anyway.
Yeah, I didn't let us do this.
Okay, it's organization policy. Then you can go with the zip package as well. So if you have some blockage because the installer are detected as installers by Windows, you can go also with the portable package as the same. There's a zip file that you can just extract, and then there's a JIPipe executable inside. But if you are under organization policy, it could also be still blocked. This is something that we cannot do anything about. There you have to ask your IT admins to install it for you.
Yeah.
And while you're downloading things, we can also download the data for the workshop. So when you go to home and then this JIPipe Spring Course site, news site here, I added direct download links to data that we will need. So there's the main data. This is very small, like 80 megabytes only. And then there's some additional data that we may or may not need. Depends on the timing. So if we have some time left, then we can show a bit more advanced pipelines that are not super advanced, like the one tomorrow, but intermediate. So this one, the first one, definitively download. It's very, very small. Yes, I don't care. It's not virus scanned. And then the other one is a bit larger. It's like 2 gigabytes. You can just download it anyway, or 3 gigabytes. So you have it there, but I don't know if you will need it. But the first one you definitively will need. On this news page here. Updated it directly before the lecture. That's why it was a bit late. Then again, who has already downloaded it, set up your author information, and it's there. And then if you have an ORCID here, it complains that I don't have one. Actually, now we have time. I can just search my ORCID and the sultans. The poor wireless. Oh no, something is the internet. I see it. Didn't the IT say we have now few wireless problems as well? I noticed that. Yes, I don't care about cookies. So you can also find all instructions regarding installation, so you don't have to remember everything here in course in the documentation. And there, when it loads up, which it doesn't currently because it's stuck here somehow. Why is the wireless so slow? Stop that. We can do this later. Of course, now during the course, the wireless is broken. I assume everyone has does everyone have it installed now? So then I downloaded also this, so at least this basic workshop data download already. You can then extract it with a zip. Don't double click it because you need to access the individual files inside. We need to really extract them. This is a bit of a mistake from Windows side to show them as a folder. They are not folders, they are zip files. And there's a lot of images, and there's basically all the pipelines that we will build up. It's actually the same one we did last year, so I forgot to rename them. With everything in there, so you can always go back again and then just revisit the pipelines there that will build up as well. But first, some basics about JIPipe. General user interface, how it looks like. You have at the very top a menu that you probably notice, so you can find all your things that you usually need, file saving and so on. There's also backup functionality in there when you are on collecting over time projects, and they will be in the start page appearing on the left side. You can just double click them and then load them back in. And then at the top right, there's a bar that grows over time somehow with a lot of important or quick access functionality that are there. For example, when you start JIPipe, but then you say, okay, I need now Figge itself, I want to do something interactive, you can just click this image shape button and then it will pop up Figge. It's a quite new feature even. For example, I can click here this image shape button, then it will pop up Figge. Do not close Figge, because when you close Figge, it will kill everything immediately. This is just some quirk of Figge that it will do that. So I closed Figge and it's gone. And then you have to pray that JIPipe's automated backup backed it up for you. So this is the same thing as when you would start JIPipe from within Figge, which you can through the plugins menu. So be careful about that. But JIPipe takes regular backups. Of course, you have lost data before it was developed to that level. So then you just hope it made one. It tends to make one like every 7 minutes. That's like the default. You can configure it, but 7 minutes is a good base estimate. There's the Windows key. So there's also like different buttons. You will learn about them more over time, what they do. There's also like a save indicator, which is quite new as well. It shows when you saved the project the last time, so you don't forget. There's also an autosave functionality in there, where you can click this button here, and then you can say, okay, please save it automatically every few minutes, so you don't lose data at all, but can be dangerous when you're experimenting with your pipeline and you do some destructive operation and it's saved automatically. So to get started in JIPipe, you click this new project button here, and then it will jump over into the actual diagram where you can do the workflow setup. As mentioned before, you should really set up the authors. This is a bit older UI, but it's similar principle as with the older UI. If you have an ORCID, put it in, because JIPipe then will use that one as the main information on who you are compared to ORCIDs. Then it can keep apart people who have the same name, which can happen sometimes. So when you switch over to the actual diagram, by clicking this green big button here, new project, we'll switch over to a automated, like a base setup where you can get started immediately. The basic structure is the following. You have a big empty area by default. This is actually the pipeline that you will build up. There's then the diagram that you will basically build of the workflow. And then here on the top of it, there are different tools to work with this pipeline. By default, there's like this mouse tool, and then there are different ones for moving things around, for annotating the graph, like putting some boxes around areas. I will show them to you later on. Then let's stay in this theoretical one. When you add a node, I will show you how to add one. Then it appears in the pipeline. Actually, here I expected how it's done. So it will start up always with this quick guide info, like it shows all the basic information to get you back in. So okay, how do you drag it? How do you navigate through the pipeline? And so on. You can reread it when you click over this quick guide again. And there's a button, start adding nodes. It will then jump over to this add nodes panel. You can always go back to the quick guide again and again. And this lists all the about, how many? We have 3,000 approximately, I think, nodes available. Let me quickly double check. Getting started. 2,000 in this one. And we will over time navigate the ones that are important to you. These are the nodes. They are categorized by different categories. And let me, for example, you don't have to do that one. Add one that is called auto threshold or auto threshold 2D. You can drag them in, out of this box, or you can double click them. Then they will appear at this little cursor here that you can make when you click the diagram. Then I put it here, and then I double click it, and it will appear here at the cursor. And this is when you select a single node, it will look like that, where you see on the right hand side by default activated a panel that shows its parameters, where you can set up its behavior. And then below it, there's documentation. So these panels are very flexible. You can switch them around and move them also to other locations. That is like the default setup. If it, for example, switched to this error panels, then you can click documentation to bring the documentation back up. Or if you don't need the documentation, then you can just click it away so you have more space for the parameters. For example, I don't need the documentation here, I can click it away. And usually this documentation is quite helpful. It has some additional information, who made something, also which publications are associated with that specific functionality, and other information, okay, what goes in, what goes out of that one, and where it is maybe located in ImageJ approximately. So if you're familiar with ImageJ, JIPipe has internally some database how they are called in ImageJ if they match up. So you see this one I found with this IJ menu basically says from ImageJ, ImageJ naming, but it actually is JIPipe's node. So, and then when you are very familiar with ImageJ already, then you are familiar with the ImageJ workflow. You go in there, go file open, and then, or you drag it in, and then you will get an image window in ImageJ. But in JIPipe, this is a programming language where you literally make a script, the equivalent of an ImageJ macro, just visually. There you will define what will happen, and it doesn't happen immediately. Like in ImageJ, it happens immediately, and then hopefully you have a macro recorder running to record that, so you can repeat that. In JIPipe, you define what will happen as a recipe, and then you later execute this recipe, then it will actually do it. But then it's already saved, and you can just repeat it how many times you want. It's just a different idea behind it. So basically, from that point of view, this recipe is living in this graph area for you. So, and then we will actually start with the first data. So hopefully you downloaded already this data here from the basic one that is only 80 megabytes in size. If not, then you will find it here in the JIPipe Spring Course interactive workshop data. Under the download, it's already there. Some people plug it in. And then you will get like this small zip file. In Windows, this is just the stupid thing that it shows them as a folder, but you cannot really work with them when they are like that. You have to extract them. And this is, I don't like this concept of showing them as a folder. That's why that you have to right click and extract them. And then you get a proper real folder, not a zip folder that is compressed. And there is then the data in there. So lecture data, there's all kind of data. Don't ignore that they're all called JSC2026. They're still the same data as last time because it doesn't need any changes. And then we start here with this blob single. This is just containing a single blobs image. You can double click it, then it will show in an image viewer. I don't need OneDrive, thank you. And then looks like that. This is one of ImageJ's standard image sets that you can use. And then what we are gonna do is, okay, I played around here with these nodes. I can just drag an area around them and delete them, or press delete on the keyboard, so it's empty. And then what we're gonna do is, the simplest way to get data in, at least in JIPipe, you take the file and then you drag it in. So you see the cursor here following it, it's a bit behind the preview. And when you let your mouse go, it will make a node that contains basically the information where this image is located. It's not the image itself. It doesn't load anything in yet. It's not an image. It's just basically a file path. So location information. That's what the path is. So that's why you should not use zip files, because it will, I show you what happens when you do it with a zip file. I have this from the last years as well. So when I go here in the 02 blob single and I drag it in, it will do something, but then use like a temporary folder in there, and it might then get at some point deleted and then stops working. So just do it safely, extract it first, and then nothing gets deleted by Windows automatically. Because when you do it like that, Windows deletes it automatically at some point. So we have now that. This is also all tracked in the slides, so if you need to go back, you can always open slides, and then they basically act as guidance to do the interactive part as well. And I follow them very closely as much as possible. When you drag in the file, it will make a new node that contains information where this file is located. That's important. It's not the file itself, it's not the image itself, it's information. So in these nodes themselves, there are basically instructions, and have something that goes in, the input slots, and then something that comes out, the output slots. And the data that flows always from top to bottom, like with water and gravity and so on. It flows always top to bottom. Here, for example, an image goes in, and then another image goes out. And then, because I was asked once regarding, because all the time that people needed this information, how to actually navigate around in your pipeline. This is why we recommend have a proper screen and then have a mouse at least. You can move these nodes by dragging through by the colored area. So not this gray area. It will do something different. I'll show you in a minute. And or you can select them and then just use your keyboard's arrow keys. And you can also move around the camera by holding the middle mouse button, or you use the map. Let me show it to you in person. So if I drag by the gray area here, then it will make a connection that we will need later, but it doesn't drag it. If I have to drag it by the colored area, or it's usually in the middle, or if it doesn't have an input, it extends upwards, then I can move it around. Or I press my arrow keys, sometimes it doesn't work, there you can have a bit precise options as well. And then moving around, you hold your middle mouse button, and that's why you need really a mouse. Then it will, you see I can move the area around, and it will extend into all directions automatically, so it will accommodate the space. It's basically theoretically infinite. You see here the minimap updating as well based on that, so I can move by that around as well. This is really important for larger pipelines as well. So when you can also zoom in and out if you want to see more. The standard way is you hold Control and then you scroll the mouse key, or you use the zoom control. There are also there's also a key binding as well. So let me zoom in. So I hold Control and then I zoom in with the scroll wheel on the mouse. And then it can increase, or I can use here the zoom control as well. You can also turn it back to 100% to reset zoom, and it will turn back. Sometimes you get lost in the pipeline, especially when they're large enough. Let me make a condition where they are, when you are somewhere in the space. And there's a button that helps you with that. You just basically press this little button here. That's next to the undo button. Or you press F12, it does the same thing. So I'm somewhere here in the middle and I don't know where. Okay, I could just click here and then I find it. But the area is super large too, and I can get lost again in it. And then I just click this crop center view to nodes. It will basically remove the empty space around that is unused, and then you're back into view. It will adapt to the actual the size of what you have built up as a pipeline. So it will not cut anything off or delete anything. But we have only one node here, so it crops that one into view. So then there are different ways to add nodes. I hinted at it a bit. You can drag them out of this area and then build it up. There are also a navigation system where you can use the categories to select ones that you are specifically interested in. For example, nodes that are related to images, nodes that are related to working with filaments or regions of interest or tables. And you can filter down through the menu. Or if you prefer, you can also right-click these categories and then you get a normal menu. I can show it to you here. I can drag it out, I showed it to you, or double-click them, but then I also get here a menu. I prefer this actually personally using this menu. It's very quick. And you can, of course, search as well. The search function has been fixed over time, and it's relatively reliable now. And you see there are many, many nodes that do different things in there. And there's one that's actually not shown in the lecture because it's extremely new. You can also double-click the area. Then then the selection search will come up. And then let me add the first one that is here. And then it will appear there where you clicked the last time. So this is another way. It's just sometimes you want to do this, sometimes you want to do that. That's why I show it. I'm gonna delete that one. So then what we have already in this pipeline is really important to really memorize it. For some, I know that from the last years, it is a bit new concept to work with paths or think about these file paths. But these are basically just text that point towards a file. It is not the file itself. It is not an image yet. It needs to be imported. And what we did already is have this file list node by dragging it in, which contains in itself, in its parameters, the information where this blobs image is. You can even review that information by clicking the node, and then you see in the parameters there is a list of files, and there you see the full path to the blobs.png file. This is then what JIPipe can use as information to later do something with it. And this do something is then a next step that you would add. And this depends then on what you want to achieve, what this next step is. And for a very simple case, like in ImageJ, where you just drop the image in, and then it made an image window for you, we want to import an image. This is done by a node that's called import image. Imports an ImageJ style image. I'll show you how it's done. So you can then go with whatever method you search. So I'm searching here for import image. There are different importers, so you sometimes have to type in really out the full name, because if I just say import, then you can import files as all kinds of things, like in ImageJ, say import XML, import 3D ROI. So type out import image, then it will find out this specific one. And don't mix it up with some others. So for example, import image from ImageJ, which does something else. It runs some ImageJ-based data queries. So it's basically taking an image window and turning it into JIPipe, its own format. But you want specifically import image. So, and then I'm dragging it here. But this is yet not doing anything because this is incomplete. We need to make a connection to tell JIPipe we want to take these blobs.png and then import it. It doesn't understand unless we make a connection. And this is indicated, a missing input, by the red color in there. Or you can also right-click this slot here, and there is a menu popping up that says not only information what it is, like it's a file that comes in and then how it processes the file, but also that an error or an information that it's missing an input that it has to work on. And connecting nodes is something that you have to get used to. There are two main ways to do it. You drag a line or you use the menu. Most people tend to then use the line connection method. You start basically at any of these gray slots. You can choose the input or output, it doesn't matter. And then you drag, when you hold the mouse, you see there's an arrow following you around. And when you drag it on the input, it will turn green and snap into place. And when you let the mouse go, then they are connected with each other. And when I drag the node around, you see it keeps following it because it's internally now tracked that they belong together. You can also use the menu as well. Right click and then there's like an option connect to. And then, but it's mostly cumbersome to use that one. Maybe very long range connections are used are for that. Then how you can disconnect them is you drag either the node again, or you use the menu. Show it to you both. So you can, when you drag it again, because there can be only one connection, then JIPipe sees, okay, this is something you want to delete. Then it will snap into place, but with a red arrow, and then it will be gone afterwards. This is the one of the three main ways. It's actually one is not explained in the lecture yet, in the slides yet. You can do that, or you can, if you have many connections to something, you can also right-click it and then disconnect all. Then it will disconnect them all. Or this very new thing that JIPipe 6 only has, where you can actually select the edge itself, and then you can press delete, or you can use here in this panel on the right hand side delete, and then like in any tool like in PowerPoint or something, then you can just reconnect it quickly. But often you get extremely quickly used to that one because this is super fast. So then you see I can just do it in any direction because data flows always from top to bottom, so it doesn't matter which is the direction connection that you drag. And this will get some used to, but then you will probably quickly learn this. Everyone has learned this extremely quickly and get used to this style. And it's in the end very efficient. And then now we want to run, because as mentioned before, we have built a recipe. We now have to actually apply this recipe and then actually tell JIPipe do this now. And running nodes is done with this prominent button that already has like a play icon in the middle. And when you click it, then you get confronted with a lot of different options that depend on what you want from it. The main ones are update cache, cache intermediate results, update predecessor cache, and then these show and run and show results, although they are for special cases only. And don't worry, I explain them what they do. So let's see, they have a pipeline that is a bit larger, that's already connected up, does multiple things. So if I click in the very bottom one, this is like a visualization mode actually, display button, and then tell it to please update cache. What it will do is, does this one work? No. Then it will basically run everything because it needs to calculate the intermediate results for you. But it will discard all these intermediate results and then only keep the one that you are interested in. We'll show it to you in person as well, don't worry. Cache intermediate results will do the same, but it will keep all the intermediate results as well in memory, so you can look at it. So be careful with the memory meta. Cache intermediate results is often useful for that, but until the final version 6 of JIPipe that will solve that is done, there's your memory is limited regarding that. And even in JIPipe's final version 6, it will put it somewhere. It will put it on the hard drive, so you can fill up the hard drive with that. Then there's a special one that is sometimes useful for when you want to test different settings of an algorithm, but you don't want to repeat all the intermediate steps. It's called update predecessor cache. This basically takes the inputs, only keeps around the nodes that it needs as an input. Like this one goes into that one, so I'm keeping that around, and then this one I also need, so I keep that in memory, so I can just try out different settings for this one here and then repeat it, or just rerun it, and then it doesn't. It's just way faster like that. JIPipe's execution system is actually smart, and what it will do is it basically goes up the pipeline and check automatically to see, do I even need to run this? Do I already have something in memory regarding that? For example, if these two images are already in memory, or like these two data here that are in there, they have this indicator, then, and I tell it to run that node down here, then JIPipe knows this one is already there, this one is already there. I don't have to run them because I can just reuse the data and then it goes down from there. So you can pretty much rely on that system. It has some weird edge cases if you have more complex nodes with Python code in there, but maybe they will be resolved soon. But you can basically trust the system for you. There, when you run them, they will have a little indicator down here where it indicates that for this node, this output is in memory, and you have a result basically ready for it, and switch it to a result view. I will show it to you in person, everything. So I'm back here to my pipeline, and let's show what I mean. So if I run update cache, then it will import the image. Sometimes there's an ImageJ window popping up. You can close it because this is some weirdness of ImageJ that it likes to open windows. And then you see that this one here has the indicator down here to indicate there is data in there. But I ran update cache, so the file lists output, which just basically makes a conversion from the path into something that JIPipe can work with, is not in memory. If I rerun with this cache intermediate results, then you see that this will also be cached now. It's basically in memory. It's very small, so it doesn't matter really much for these file objects. Let me check the magnifier. Yes. But like that. And then when you run something, it will automatically switch to this results view, by default at least. So when you want to go back to the parameters, you just go there. You right-click, you click here to the parameters. But then you can review the results when they are in here by clicking this button. And you cannot only look at them from here, you can just double-click them, then they will open up in an image viewer. This is JIPipe's own image viewer because it needs to be able to work with JIPipe's own systems, so it doesn't use ImageJSON. But there's a feature where you can export it, for example, into ImageJ, and then you can work it in ImageJ, for example, or in Apari, or in a 3D viewer from ImageJ, etc., or export it as a file. And there you have basically most of the things that you would need. You can do the contrast settings. You have these ImageJ standard contrast options. You can even set the LUT, like make a color map, and it's colored. As I explained yesterday, this looks always impressive to everyone using these color maps. But this is then non-persistent. This is not you editing the images, you're viewing the data and you don't edit it because JIPipe is supposed to edit the data, not you yourself. ImageJ is the tool for interactive editing. JIPipe is an automated tool. So, I explained as well. So we have that one. And I have here different false coloring as well. This is the Viridis one. There are information about the image on the bottom left, but the same one that ImageJ shows as well. So it's very consistent with each other. So, and if you have multi-dimensional data, like in ImageJ, the controls will pop up at the bottom in this viewer. There's also the animation tool, and where you can jump to specific slices and go next and back and forth in the slices as well, which is a bit improvement from ImageJ's system as well. And then let's do something let's actually do something with this data that we have, and this is extracting the blobs of that one. A very standard approach for these blobs data to show how ImageJ works. You can do the same thing in JIPipe as well. So the standard approach for that one is we have the blob data as original, then we do some kind of pre-processing, as I explained yesterday. We can do some smoothing or noise reduction. Then we do some thresholding, and then we can do some ImageJ and JIPipe specific, this implementation of their regions of interest and associated measurements. And then let's do that. So we have here the image already imported. And now, if you remember, there are 3 algorithms that I presented yesterday for noise enhancement. And you will find them all in JIPipe as well. You can search for them, or you can navigate via this tool here, where you can go images and then let's not do the categories because I never find them. This is not helpful either because it's such a gigantic menu. It's, I think, in smooth somewhere, but it's on Windows it's somehow cut off. So let's search for the 2 other the options that's via the search. So we have the Gaussian filter. Why is this when I search Gauss with? I have to fix this at some point. So Gaussian blur 2D is one of them. Then we have the median filter 2D. So this is the one that how it's called in ImageJ with median ... And then in JIPipe, the actual algorithm is called median filter 2D. I'm just dragging them all in. You can search them. And then there's also the box filter or local average. These are the 3 ones that I showed to you yesterday. And this is then now what in JIPipe it's really useful, where you can just make branching. So let's, for example, start with the median filter. Let's drag it in and connect it again. And then if I run it with update cache, it runs very quickly because anyway the data is quite small, but it will know that this import image here is already present in memory, so it will just reuse the output and then apply the median filter there. I can double click it, and then if I compare it with the original image, it's a bit different. Okay, let's maybe put up the median filter's radius a bit more, so it's bit more visible. Let me first quickly set something in Windows. I noticed something that is really annoying. Where was this? And why that you can catch up with these settings here. Where was this? Personalization. Where did I put it again? They always move these things around and I never find them again. How it's called? I need a browser for that. Disable window snapping bar. Setting system multitasking. Where did I put this there of all places? Okay. There was a weird annoying Windows 11 feature. It's extremely annoying. So the median filter, but you couldn't see anything because by default it's like only 3 pixels, the whole width of this filter kernel, remember from yesterday. But we can change the parameters. We go into parameters, you can increase the radius, for example, to something large, 5 or something, and there you would really see it. see how smooth it is. But it is still, the edges are quite hard. And as shown yesterday, the median filter does that it preserves the edges and doesn't smooth them over so much. We move this window out. And now there is something that is very nice in JIPipe, because unlike an image J where you usually work on the current image, although sometimes it makes a new image, or sometimes you have to duplicate the image and then you work there. Here, JIPipe takes care automatically of duplicating the image for you. So just drag it what it will do, and then JIPipe takes care of that your data doesn't get destroyed. So I can just make a parallel branch where I can just use the Gaussian blur as well, and it will not influence at all this image. Here, this original image is still the same as before, because JIPipe takes care of duplicating the images automatically, so nothing gets lost. Gaussian blur, let's try it out with a higher sigma. This -1 means basically you just take the sigma x, because with Gaussian blur you can also make a sigma x and sigma y in different directions. And if I run that one, then you see it's very blurred. Let me switch to this view mode. If you just want to view the image, then you can click this little button here down there next to the pin, then it will basically turn off all the UI. Just make a montage. So it's actually part of the thing, so I can show you how to make a montage. It's not that hard in this mode. Let's make also the box filter very high, like radius 5 or something. And then if you want to compare images side by side in one image, there is actually a node for that. It's called make montage. It's basically image.js montage, but rewritten from the ground up. Make montage, and then you just drag all the images in, because it's a node that has, you see here this special indicator is a many-to-many processing, like a merge one that can eat multiple data at once and then does something with it. And then I run it, then I get a montage. By default it's like vertical, but you can configure it, how it behaves. Let me keep this window open. For example, I want to tell it, okay, please make only one row. And then you can keep these windows always open, because they are internally connected to know, okay, they are from that node. You can run the update cache from inside the window as well, so you don't have to reopen everything and so on and so on. If I rerun the update cache here, then it will update itself automatically for you. So by default, the label is not set, because I did not set up any information that it can use for the labeling, but this is something with annotations. This will come up a bit later, and will populate automatically depending on how you set this up. So make montage, and then you can force the number of rows as well, where you can compare these images visually. There are also automated versions, like different algorithms to compare images as well. This is a bit advanced topic and not so trivial, actually comparing images that in a way that makes sense. You can see I can move this around, it's still connected. Yeah, so by default it was the rows, it goes down. And then I set in the parameters, you can then configure it, okay, please force the number of rows, because I want them like horizontal. It uses like algorithm to determine this automatically, but it's usually, you want it in a specific way. You want these many rows, these many columns. It's actually the same algorithm that image.js montage uses, but it's very enhanced and can do a bit more than image.js thing. It can also montage any image type basically together, and you don't need to convert anything for it or ensure that the bit type is so on. Yes?
What is the difference between make montage and create montage?
Yeah, they're actually the same internally. Sometimes they have this is the actual, so this is a technical detail. This is the actual name, internal name of this node. IJ1 dimensions import to montage version 2, because it's a second version. And then create montage. When you go down into technical detail, it's actually the same. It's just the JIPipe has some aliases set up. So it's basically for the ImageJ users who come directly from ImageJ and search for a function, how they are called in ImageJ, because they're used to it. This is why there's this little IJ menu where the JIPipe nodes are organized in the best way possible, how they are approximately where they are in ImageJ, and this includes the name as well. So they do the same thing. This is the ImageJ naming, make montage, and you see even here in the documentation it says actually create montage. And this is the actual JIPipe style node name. There's sometimes a bit confusing. But you can always reset this name because you can customize it. When I delete this one here out, then it resets the name to the original intended name internally. But the system can then also allow you to describe better what is going on with the node here. You can set a custom name. For example, I can just compare the noise reduction visually. This is actually not what all of these workflow engines allow to easily edit these namings, but in JIPipe it allows it. Okay, we have this one. Let me keep it here. Well, this one I can delete. And then let's continue with the blob analysis a bit. So we have this median filter, which is super high set. So it's really set to a high level. And then let's reduce it maybe a bit. So let's run, go to the settings here, maybe reduce it to 3. And then it doesn't matter where you run the cache. So if I rerun this cache here, this one here will also update itself. So it's changed. So it's like internally linked up with each other. It knows that it came from that node and it knows when it needs to update itself. So you can keep them always open and compare also visually. 3 is usually good for this one. Anyway, nothing is actually good for this one. It blobs it. You can just threshold it manually, and you can just threshold it immediately, and it will yield a good result. So we have now, we continue with this median filter because I chose to. You can go with any of these, or don't build up this whole stack of different filters that you can compare. You have the full freedom here. And then let's just auto threshold it. So when you search threshold, then you find immediately ImageJ style of naming auto threshold, or JIPipe style naming auto threshold 2D, really indicating that you are doing a 2D threshold, not something that uses all the statistics from all slices, although it's also not really to JIPipe's auto threshold. If I drag it in, then connect it to the median filter, then run it, then it will run. So generally most JIPipe nodes, they will do work by default. This is what the idea behind them, that you just use them and then you have something that you can work on and then change and modify. By default, when you review the parameters, it has a lot of parameters. It will use ImageJ's default threshold, and this is our most important parameter. And this is why it's indicated with this orange indicator to show you, okay, this is an important parameter. Please check if you're happy with that one. And there are then all the other ImageJ threshold methods, except try all, which is not a thresholding method; it's a comparison. You do this a bit different in JIPipe with a different system that is then more flexible, and it works. If you have then later a bit more complicated thresholding scenarios, so for example you have pre-segmented an area that you want the threshold to be calculated based on that area, on that mask or ROI, there you have also the ability to say calculate the thresholds based on inside a ROI. Then it pops up an additional input for region of interest, or inside a mask. Then it will change itself to you need now a mask as information. Or whole image, then it will disappear. You have a lot of these additional settings sometimes in JIPipe where it's extending on whatever image they provided you with, so you have then way more flexibility. You can even do 3D threshold as well with this node, even if it's called 2D threshold, by saying multi-slice thresholding, where you can say, I want to combine the slice statistics, the histograms for all the slices, and then use that one for thresholding, or make a custom combination function. Then you type in a formula, basically. This is super advanced stuff, and sometimes it's useful to know that sometimes these exist. So it's a good idea to review the documentation. There is also a full node documentation as well for each node. That where was it? I think it's here. No, this is the category documentation. You can go also here to help, and then you get like a full integrated database of the nodes, and for example, auto threshold 2D. And then you can read up on all the parameters and what they do there and what belongs together as well. Or you use this small system here where you can just click the question mark. Yes?
If a threshold, usually or use the whole montage as one image?
The montage is one image. So,
okay, so basically the left image would influence potentially results on the right image.
Yes. The montage is more as a visualization thing, because you will have influences between, because as I remember, as explained yesterday, these auto threshold methods, all of them from ImageJ, they use the image histogram as the basis. So if you add 3 images, then all the histograms are merged together in some way, and it will do something. Does it make sense? This is then something that you have to decide. So rather you would go threshold each single one, and then you make a montage, which you can do as well. Example, let me reconnect these this way. Okay, this was not needed. There's a button where you can just duplicate a node. When you hold Control and then Control D, then it will duplicate it where your mouse is pointing. This way, how you can make very quickly copies. And then when I all connect them up to the create montage, then I get a montage of the thresholds. But this is of course a bit annoying when you have to do all of this manually. There are ways, I don't know when we will get to that one, where you can do this absolutely automatically. Where you then define parameter sets, how they are called, different settings of the parameters, and then JIPipe will execute them all one after another, and then later you can collect them up automatically and then do a montage or do some selection, which I use also for some real-world pipelines, where it's testing different hypotheses, and then it's choosing based on the criteria the best one, for example, different voice thresholding methods, and then later I pick the most round voice out of the one that were segmented. So this is then possible. It's a bit more advanced, and you need to rethink a bit in your head how this data flows around, but this is definitely possible. So let's reduce it a bit down. So we have a simple pipeline. Let's stay with the median filter and then auto threshold 2D or auto threshold. And then we do the same thing as an ImageJ. In ImageJ you do this find particles thing. So where you do here this analyze particles. Let's move this to the side so I don't close it accidentally. In JIPipe it's called find particles 2D. Don't mix it up with the IJ3D find particles 3D, which is a 3D version of that. Find particles 2D. This is the equivalent of ImageJ's particle finder. It will actually also produce the same outputs. It produces voice as a data, the equivalent of the ROI manager, and measurements that you can look at. So I can just run it because it's by default set up, so it runs. And then you get out 2 data. because there are 2 output slots. By default, JIPipe will display all of them at once, so you have a big table sometimes, but then you can go in the results view and then also switch. I only want to look at the ROIs, I only want to look at the measurements, or back to all outputs. You can again double click them, you can always double click these results, and then you see what JIPipe sees these image JROIs are. So in image JROIs, I hope that I have like a description of that somewhere here in the thing. So it repeats, so you can always follow along. ROIs particle finder. No, I never explained that. So in ImageJ, ImageJ hides this fact a bit, that these ROIs are actually just outlines. They're literally there are just circles that have custom points where they are. So nothing else. They are not associated to any image, although they can be, but technically they are just outlines of some region. And JIPipe makes really use of this fact to really separate these ROIs from the images, so you can apply them anywhere and they don't use up so much memory in the end, because the next image is expensive while ROIs are very, very small in size. And then when you double click the ROI by itself, it will make basically a black image based on whatever the ROIs cover, and then display it for you. And there's its own small ROI manager in JIPipe that you can open. It's not as so fully featured as ImageJS because it's not meant for being interactive use. It can do some basic measurements via this 2D ROI thing here, but generally you can, for example, also tell it to move it please to ImageJS ROI manager. You get also measurements in the equivalent of ImageJS results table. The benefit here in JIPipe, because it is meant for batch processing and you can have multiple tables, as many as you want, in fact, and you can customize and work with them very way more than in ImageJ you can do. Otherwise, in ImageJ you would need a macro for that. In JIPipe you have a lot of algorithms that are working with tables, summarizing them, adding new columns based on calculations and so on to come up later, I think. So then we have those. Let's maybe do a visualization. And there are actually 2 approaches for visualization. There's the one that is ImageJ is using. This is using an overlay. This is the same thing as when you go in ImageJ and then you click this show all thing in the ROI manager, so it appears on the image that you have selected. In JIPipe, this is explicitly called, you want to set an overlay on the image, or it's set overlay. There are the ImageJ variant in the ImageJ naming, set overlay, or set 2D overlay, the JIPipe naming. That node needs 2 inputs. It needs a ROI list, so basically a ROI manager, and something it needs to set the ROI on as an overlay. And then let's say we take the original image, and then if I update the cache, then you see already in the preview this yellow highlight, and then you get basically the same view as ImageJ would do. It draws the ROIs on top of the image in the viewer. There are still active ROIs when you click this integrated small ROI manager, that you can select them. The image has still its original bit depth. You still here see it's an 8-bit image, it's not an RGB image. And this is one way how you can do it. But often in the end you want some RGB render out that you then save out as a PNG file, for example, automatically, ideally. If you have something that has an overlay, you can render out this overlay. This is basically the same thing as flatten in the ROI manager. It's called render to RGB, I think, or render overlay, I think, is more fitting. Sometimes they have overlapping purposes, these nodes. And then when I run that one, the same thing as flatten does in the ROI manager, I get actually a proper RGB image out where the overlays are rendered out on top. Sometimes it messes a bit with the contrast. This comes from ImageJ's side of automated contrast enhancement doing that. Or you can do this in one step. That is a separate node. It's called convert ROI to RGB. To the ROI to RGB, it will also again receive a ROI, and then an image that you want to draw on top. This one here, and then this one will work as well. Let me move out a bit here so you can see this. You can actually double click these edges, then they will make a little control point here that you can move around and organize your pipeline. That's what's new in JIPipe 6. Then when I run it, then it also produces directly an RGB image. You can also do some fancier stuff in there and control it, override, for example, settings. And for example, tell this node here to control how the filling is behaving. Do you want labels be added by it automatically? And JIPipe can actually do a bit more with these labels and image shade. You can also render the name or custom information out of the label using JIPipe's own system. Or override like line colors. For example, I want it not yellow, but I want it blue, then it's blue now. And no one prevents you from, if you have multiple ROI lists, to just stack those on top of each other and then build up your final visualization one by one. 1030. So yeah. And then I check in my presentation if I'm in here. There's everything again is explained in here, how to do it, how it looks like in the end, and you will be provided also the files for the JIPipe files that do all of that what we've shown, maybe not the montage thing because I deleted them. And then in the end you want to save your project. And there's a bit of thing that you need to be aware of when you save your projects in JIPipe. So when you just control asset, you have to remember that JIPipe will not save the data with your project. But imagine you have like a terabytes of images. It will not put it into the JIPipe file. This is way too large, and you don't know where they are, and you don't want them likely to be together with the JIPipe pipeline. So it's basically just saving a macro, a script that is relatively small. And JIPipe has a standardized way for you to suggest saving it, so it's portable automatically without you setting anything up. And the way is you save basically your project file next to the data in some way. For example, what I like to do is I define this is my project folder that I'm working on, and the data is maybe sitting here loosely in there, or you have subfolders. You can have a hierarchy of subfolders next to the project file, and then JIPipe, what it will do is it will internally know that is next to that relatively to the project, and then automatically change the paths inside to adapt them to the to be stored there. So for example, you will see it now when I show it. So I have this lobster PNG. When I check the parameters, you see here's a super long path, because it is still an absolute path to where the file is. But when I save it smartly, where did I put that? Here in this basic workshop data and lecture data, and then lecture 02, let's call it JSC2026. Then I save it, then it's not only saved, and it updated here that I saved it less than 1 minute ago, but when I rechecked this one, it shrunk down the path because it understood, okay, this is something that is relative to my project work folder. And this way, you can just basically take your whole folder and zip it up, and then give it to someone else, put it on another computer, put it on a server to be run, and you don't have to take any care of setting anything up, so it's portable. That's very useful. There's another system in place as well when you want a publication-ready data. This is in this publish menu. You can explain this later when we have time. But this is then like our first pipeline. It's actually where we should anyway make this little break, and where I set a break as well. Let me just quickly mention stuff will come up later on. So we have when you save it, JIPipe knows you have like it's called a project folder. That's where the project lives in. But you can also define custom folders yourself that you can reuse within your project. There will be actually one part of the exercises will actually require you to do this in modifying the project in a way where you can basically change standardized folders that you define yourself inside the projects. And this is within the so-called project overview. You don't have to follow that one, this will come a bit later. So when I click that thing here next to ImageJ, this is basically the project overview. This will automatically open up if someone opens your project who is not an author. And this is intended for reviewers, for example, or for people who are not knowledgeable about the project. They need information. Here is basically like a control center where you can set up descriptions, how to do it, what is available, and important parameters and so on. You can basically take parameters from the pipeline and put them here into a separate view, so the reviewer doesn't have to go into the pipeline and hunt down parameters there. They can completely control this project from within this view. And this is why it's important to set up your authors, because then JIPipe knows, okay, this is somewhere I don't know. I will go switch to this mode here instead, so they can be confronted not immediately with whatever you were doing in the pipeline. And there you can also add like these custom user paths and so on. This will come up maybe a bit later as well, how to set up specifically that. You can say I want to add a file or directory and then basically add them under a key that is reusable. So I think I will explain this later again. And then you can reuse this key within the project itself. It's an important concept in general to make the project portable. So, okay, let's try it. I add a file or directory, and then I can say I want a directory. Oh no, the Windows directory search thing. You can actually turn this Windows thing off and switch it to JIPipe's own directory searcher, which is a bit better. And then, for example, I have here my blob single folder, and I call it inputs. There's a key that is reusable everywhere. And then when I run this add project directory thing, project user directory node, and I have to tell it which key I want to reuse. I called it inputs. Then when you check again what comes out of it, it's taking the path that I selected before. And the idea would be you'd set this up once, and then instead of dragging things in manually, and then later on when someone comes and they want to just run your project, they don't have to go here and change anything in this view. They just go through the project overview, and then they can here customize which folders are in. Then you write a description where you say, okay, please reference the folder with the data that looks like that and that as inputs, and the outputs select the folder that looks like that, and then it forwards it all basically into the pipeline automatically for you. And then this basically this system. It will come up a bit later, and if I miss something, then Zoltan can explain it, because he makes heavy use of that in his advanced pipelines. So they are extremely portable and can be easily reused. But then I think we should have a pause break now, a short break. Oof. Yeah. So anyway, no one wants a break, I think, but and so if you ever close something, then here in project there is a backup manager and this will keep track of all the backups that JIPipe automatically created. It will create backups even of projects that are not saved. So if you accidentally close the ImageJ window, then just go back in here and you can restore them. It will is automatically to be configured to automatically clean your backups up, like it keeps hourly backups, daily backups, weekly backups, and then month, years as well. So to ensure that you hopefully have something to recover when something goes wrong with your projects, or you deleted something accidentally, or your hard drive died. This is stored in your user directory, independent of where you stored your project. So let's save that. Was I'm done with that one. 3. So, okay, what we have now made is like this basic block segmentation for JIPipe. Where we have a simple pre-processing with median filter, for example, and then some auto thresholding with some method you can play around with them, and then the equivalent of ImageJ's particle finder that automatically also generates noise, and then you measure them out. But we need to know what nodes are there to use. There are like 2,000 nodes, and I cannot give a full comprehensive guide on all of them because they are sometimes very specific and sometimes imported from ImageJ automatically. But yesterday I built up this like toolbox that of different nodes of different image algorithms, image processing algorithms that you can use then later on. And this use comes now because I sat down and show you where these are in JIPipe. So there is a in your folder or in this project a project in there that basically showcases all of them in one JIPipe pipeline. So you can, and it comes preloaded with data, so you can play around with them directly in there as well. Let's see if it's actually there. Project open, and then, oh no, there it is, toolbox.jip. When you open a new JIPipe project, then it asks you if you wanted to do it in this window or in a new window. New window would then just make a new window. And then by default, I set it already that it's showing here in this project overview. Then you switch to the compartment analysis. Either go via this Go To button, or it's usually open up here. And then there's everything. All the different algorithms that I showcased. Where are the annotations? So they're fine. It's an older project, so. But these are all the algorithms that I showed yesterday. So, and as a general chart of what does of important nodes that you will use in JIPipe. For example, you have the ones that use a file list, for example, file list, that where you provide input paths and then it turns into something that JIPipe can work with. Then you can also automatically explore paths in JIPipe directly. For example, if you give a folder path into JIPipe, you can tell it to explore all files in there and also filter them. For example, if you're interested only in TIFF files or CZI files, you can do very elaborate filtering in there directly, and you don't have to do anything manually anymore. Just type it in and come up with a good filter. Then the import image node is the basic ImageJ importer. It behaves a bit differently than when you drag it into ImageJ. It has some automated features where it's like detecting automatically based on the file type which system to use. For example, for anything that ImageJ natively cannot read easily, it will forward it automatically to bioformats for importing. But if you want more control over anything bioformats, there is a specific bioformats importer that would allow you to actually configure the settings that you see in this bioformats dialog, where you can set the series and where you can change some access orders and other settings. These are all exposed in this bioformats importer. It also, you see this icon is a bit different that comes out of it. It's a so-called OME image. It has the metadata from this bioformats OME TIFF stored inside there. And then there you can find a bit more advanced use nodes where you can read out information, for example, the calibration information or information about your instruments directly from this file. And then use this information in JIPipe to do something with it. Then pre-processing, you saw already a few. You have like the median filter and Gaussian blur as well. There's also this contrast enhancement in there. There's this, in JIPipe it's called histogram-based contrast enhancer. It does the same thing as ImageJ's one. You can do histogram stretching and equalization. You can do edge detection with Sobel as well and ablation. There's also a canny edge detector implementation for you there that you can use as well. And you can change all the settings. And the block detection, ablation of Gaussian and difference of Gaussian, depending on what your needs are. Morphologic operations are all combined into one node where you can then select which operation you would like to apply and what is the radius and what is like the shape of the operation, because this I left out yesterday, that you can actually set the weights, for example, to be a round shape or a diamond or a square. And then there you will find it all in this node. The search will expose you different pre-configurations. For example, if you search for top hat, then it will find a pre-configured morphological operation node that is preset to use a top hat operation. But it's just the same node and you can change it always. Then this came up also at some point, like what is very common is masking out parts of an image where you want to set some areas to a value, for example to black, to erase it in some way. There is a node for that for commonly used for grayscale image, set value to value grayscale. There's a variant of it for colors as well, where you can set the color. This node can be configured similar to how I showed how this auto threshold can be configured, where you can tell it to use a ROI or a mask as a reference, where you can say inside this mask, inside this ROI, outside this mask, outside this ROI, or a whole image in some way. And you can configure this all and it will adapt itself, as you have seen, where it switches out inputs depending on that. Then measurements, there are actually two systems, and this is also a bit inherited from ImageJ. ImageJ's standard way of measurements is the one that we used already, is this find particles with regions of interest. And they are very, very fast. They are extremely low memory. They are basically just points or that describe an outline. So it's very small. But the disadvantage of ImageJ's system is that they cannot have holes, theoretically. In ImageJ, you have then a setting that it allows holes, and in JIPipe as well. But I would be very, very careful with that one, because not all algorithms can handle ROIs that have the setup to handle holes. They sometimes get confused and then get weird readings out of that. If you have anything that has holes and you want to be really safe that it works, then you use the label-based processing. So you use the connected components labeling operation. And there you have equivalents that are very similar to how ImageJ's ROI system behaves. What it will do is it will make such a label image where each connected component, like each cell, for example, gets its own pixel value. And then and this one is then independent of any holes. It can be disconnected, can have holes, can have weird shapes that are maybe not supported by voice. but it's slower because you have to store a whole image, and a quite large image too, a 16-bit image or a 32-bit image. And these can accumulate, and the processing out of them is sometimes a bit weirdly behaving, and when they try to transform it into something that ImageJ can work with, especially like circularity sometimes doesn't work correctly, and it's slower in general, but it can handle holes. So choose your choose what is appropriate for your data. Then I want to talk about now the next data that I want to present. So let's check the time quickly. Should be possible. This is the kidney data that I hinted at it yesterday a bit more. This is actually published data. There you find the publication behind it. Deutsche fluorescence microscopy data, and there was were two tasks. Because this was a new clearing method, they wanted to know the, in 2D at least, the area of the tissue itself, and they wanted to count the glomeruli, because this is like was a test case for some kidney disease. They wanted to explore that one, and for that you need to count the glomeruli inside the kidney that are basically blobs. So let's do this in JIPipe. So we have this gigantic project. I can leave that one alone. So I make a new project in a new window. So it's empty. And then click here, new project, if it asks me. So we have an empty space that we can work on. Then in the lecture data, I can go to the kidney basic data set. And there are different images in there, because this is a 3D dataset, comes from Lightsheet. But let's start simple and go with kidney.tif. It's a one single slice of that dataset. And you've seen it already, how it's done. You then go with import image, edit in, connect it, and then we can already look at it. So it has no calibration data. Remember this, at least specifically these images, but this like the pixel size is like approximately 5 micrometers within height. And then you can zoom in, and then you see here what we are looking at. It's also a bit, no, it's the original size actually, 2160 times 2560. You see that the kidney is already there. It has a is relatively bright if you modify a bit here these contrast handles compared to the background. And then the glomeruli inside the kidney are themselves bright. I have to check what was the pipeline again. So, and then let's begin with the kidney tissue segmentation. That's the first start. So let's do some basic noise removal with a median filter, and then directly add an auto threshold. So because the kidney tissue, you see it already in this preview bit, it's a bit brighter. It's relatively bright compared to the background. What do I do? Threshold 2D, and then when I run it, then you see it reacts it very well to the kidney itself, but has these issues that I highlighted yesterday as well. You have like these big holes here in the middle, and then it's this unevenness in the border that is a bit, segmentation is not so clean. By default, it uses the ImageJ default segmentation. It's like a modified isomodes thresholding, but we can try out different ones. For example, one threshold, which is the one that is a bit more lenient. And here it actually found basically almost everything, but something extra too. You see it here. It's some artifact from the imaging. But we have only the holes left, and we have the border mostly clean, but the holes are still filled. What did I do here? So it looks like that in the end. And then remember, try out different parameters where you can really configure things. You can also search through the parameters if you look for something specific. there are different tools that are a bit more advanced, like adaptive parameters and so on, in there that Zoltan will make use of. Today we will maybe explore some things. If you need help about the parameter, always click this question mark, then it will update the documentation, and then you can see what it does, hopefully. And then for as shown for kidney tissue segmentation, you have to try out what is the correct thresholding method. So I did it here with a montage that you can do in JIPipe also, although you end up often usually just use ImageJ for the interactive part, because ImageJ is just better at being interactive than JIPipe. It has interactive systems for that, but ImageJ is just better at it. And then this assessment showed Huang, as I selected, is the best one. WinError also found once, but it's too sensitive, and then it found these weird artifacts on the side way too strong. And then others seem to react differently. They react rather to the glomeruli. So that I did here basically in this example pipeline what I showed you. I set it to Huang because it's the most fitting one. But you still have the holes. The border is cleaner than with the standard operation, but still not perfect. And we have weird artifacts going on. So if we can apply the things from yesterday, we can apply this morphological hole filling. Not hole, yes, hole filling. If I add this one, then it will fill the holes. As explained yesterday, it uses a flood filling algorithm that fills the holes in the center, and you don't have to use a morphological filter for that. It might destroy it. But of course, it does not fix anything with the border, or if it's a bit disturbed like that. So in this case, it works enough, good enough. But and you would think, okay, I'm done. Are you really done? That's the question. Because when you run it on a different image, then it behaves a bit differently. So let's go here and edit the path to a different kidney. So if I go to the parameters and then I select a different kidney out of my set here, downloads, and then lecture data, and then I'm picking the, which one was it? Was 04, or yes, kidney 6 is the one that is offending. I make a little drawing. This is actually something that I explain later maybe. So I use the kidney 6 here. It didn't update because this is a bit wonky how this updates itself. Then if I run that one, it looks a bit different. It has these slightly disconnected parts, and we want to still cover them. Apparently they are still part of the kidney. And then if I rerun this pipeline here, then you see that it has not fully successfully figured out the whole area of the kidney. Because there are some issues that we need to close the holes, but the holes are touching they go outside a bit, so we need to apply the operation that I showed you yesterday, where we combine the morphological filters with the hole filling in one. So let's make some space here, and then let's disconnect it, and then let's add some morphological filters. So as yesterday explained, we have as first operation a dilation. There are different things that are called dilation, so choose the morphological operation to the dilation operation. It will name itself according to that one, so you can follow. And then choose something that is large enough. So when you go to the parameters, by default the radius is 1. It's way too small. What did I set there? Like 10 or 20 or something. While we run it. Yes, then it closed up here these holes. It left these holes inside alone. And then theoretically you could go and increase this radius even more, but then it will start destroying structures, so balance this out properly. because it will generally smooth the object. Then we can do the hole filling afterwards, which will fill the holes. But then our kidney area is then of course inflated, as explained yesterday, because we dilated the whole pixels set. So we have to undo this dilation by doing the opposite, which is an erosion. So I add erosion to it, and then you have to be careful to set it to exactly the same radius as the dilation. Otherwise, the size is then somewhere else where you don't want it. Was it 20? Let's double check it. Yes, 20. And then hole filling, and then 20 back. And then it returns approximately to the same size. You will lose a bit information because of the dilation, because of morphological operations messing with the shape a bit. But then it's back to approximately the size we want originally, but the holes are all filled, and this is then nice. Where did actually this weird artifact go? Oh, this artifact is. Oh, here it has no artifact, this one. So there's again explanation. It's all in the slides again. And I also drew this artistic masterwork of what it does. We dilate. We have here this kidney with a hole. We dilate it, so we close most holes, but then also clean up the borders. Then we fill the holes in, and then we shrink it back to the approximate size. And I figured out the correct radius by memory. It was radius 20. What we would do. Oh, I must have added this Coca-Cola to my water. And this is then one of these standard systems that you can use, like a standard pattern that you can reuse everywhere where you encounter such objects. So let's, if we go back to kidney, to the normal kidney, without kidney 6, so you can just edit the path. Let's switch to the node editing. Yes.
Can you show where you change the parameters, like where you adjust the radius?
Yes, so you go and let me quickly close this tool. You click the morphological operation, and then in the parameters there is this radius. I can add a box, then you can see it better. Set radius equals 20, and then that's it. And then I can duplicate that one here too. Then in the end we have that one. So what did I do again? Yes?
How do you import those text boxes?
Oh, these text boxes, this came up now suddenly. So you have tools here where you can add. So this is first. So this is like the normal mode where you draw edges, like nodes, and then there's you have these canvas nodes, they're called, and you cannot edit them by default when you have them. You have to switch to this edit mode. Then you can move them around. But to draw them, you can switch to this text box mode. And then you can switch, select the color, for example yellow, and then drag it, and then hello, and then you will get box thing. So I have to edit fix the UX a bit. Then if you want to edit it after the fact, you have to switch back to this edit mode, and then you can move it around. You can actually configure a lot of them. You can add the content, so hello world. You can set custom colors and change everything and so on. You can also include images and arrows as well with this system. Images you have to be careful because they can be large, and then they have to be saved in some way. But then, and they're very useful for you when you have like boxes that you want to draw around areas, as you can imagine, to highlight, help you with a bit. You can even make custom settings and then make presets in there and so on. A lot of flexibility was added. So, okay. So if I switch that one to kidney 6, but if I switch it back to kidney, you can just edit the path and then run it through. Then you see that it has this small artifact here. So I switched it back to kidney 1. Let's change the setting, kidney.tif. And then we have to get rid of that one because we should not count that towards the area of the kidney, which it isn't. So there are different ways how you can approach that one. You can, for example, tell it to please remove the largest object in some way, or remove border objects. There are different ways how to do it. But let's first start with something we anyway needed for the measurement to convert it into ROIs. And for that we use again the fine particles tattoo node, just add it in. And then what we get out is, in this case, 7 ROIs, because there are even more than you saw. Probably very small ones that are only like a pixel. And then you see, maybe I can make a, you see the outline here, that is the kidney, and then our weird object, and then it's some other small objects that we really do not want here. So how do we get rid of that? So we have 7 objects. You can then do the same thing as an image J, which will be sufficient for our case here. Because we have a very large object and all the others are very small, then we can just do a simple size-based filtering. So the same thing in JIPipe as an image J. In image J you type in like object size from 0 to infinity. In JIPipe you go to the parameters of the fine particle studio and you find the exact same settings as an image J. For example, I say the min particle size is 5000 pixels because it's non-calibrated data. I can also make a box for you here so you see it. The min size 5000, and then it should filter out that we only have 1 ROI. Yes, you see here 1 ROI only in the end. This is a very simple case. Later on, of course, in many real data, you want some more elaborate filters usually, where you control very specifically maybe multiple conditions, combine it with metadata that you gathered over the image's lifetime. And then you get also for free the area in square pixels as well, because it's non-calibrated data, plus all the image J measurements that image J takes, plus additional measurements that JIPipe also takes. JIPipe adds some additional measurements that were needed over time. For example, here these you will not find in image J RB width. This is a rotated rectangle. So if you fit a rotated rectangle, not a bounding box, around the image, and there then the width and height and the coordinates, which can be maybe useful for some operations when you cut out things or want to estimate lengths. So yeah. So yeah, I explained it in 2 here. You can do this, and then you can render out again the image as well with this convert ROI to RGB node. Let me edit very quickly. We have seen this already. Convert ROI to RGB. Edit in. I want to draw this ROI on top of the original image so I can see how successful my segmentation was. And then I get an outline. It's a bit thin, the outline. So image J, you would go to the properties and then modify the ROIs. You can do this in JIPipe with a dedicated node, but here you can also override the settings through the node itself, which is for simple cases just enough. For example, I go here to the convert ROI to RGB, and then, for example, I want the line color not to be yellow. I want it to be some cyan or something. And then I want the line width to be a bit thicker so I can see it a bit better. And then update the cache. This one here will auto update. and then you can see it way better and compare it visually if your segmentation was successful. Because this is an image and JIPipe is a workflow engine, I will show them to you a bit later. You can just automatically save them all out in a standardized way, and then you can go with your you can go to the folder and then look through it manually, and then send it maybe out. Take maybe an image for your poster, and then for your presentation out directly. And I like to do this also for like lab book things. Make a render out of everything, and then I have it tracked how well the algorithm works. Have a progress support basically of that one. So we have an area, and we have a visualization. That one I enhanced a bit in my own pipeline. You can play around with all these parameters. They do not break anyway. It's like just recreate a node if it breaks. And then the interesting thing. Or the other interesting thing, because the area was also interesting for the clearing method, this is the extraction of the glomeruli to see if there's like a significant impact on the glomeruli's count. And it was nephrotoxic something that was tested there. I can't remember it exactly. Yeah, nephrotic kidneys. And there we can then make use of JIPipe's ability. This is really nice when you compare to ImageJ, this branching ability. So we are here. I move out my notations to the side so you can keep them around. And then I give it space. And we are starting here at the pre-processed image. Pre-processed image because we have already basically removed all the noise from it. Let's assume it. And then we want to make a side branch of this task where we then handle the glomeruli in. But we have one large pipeline that will do it for us. Maybe first save it before I regret it later on. So let's save it. Lecture 03. So this one. Well, so you never want to lose data, and relying on the backup system is always a bit dicey, even if the backup system is very reliable and saved a lot of people's work already when they forgot to save it. Here, then I can also mention it, if you want it not to save always manually, just click here this autosave, then it will autosave it all the time. But this has its own dangers, as mentioned. If you just experimenting accidentally delete something, then it's saved. This is the disadvantage of that. So for the glomeruli, you have to handle them a bit differently. So you saw already one of these thresholding methods. They looked very good at maybe handling the glomeruli. But if you look at it a bit closer, then it was the yen entropy. So let me make a bit space so you can see the parameters. And if I switch the method to, for example, yen, then and update it, and look at it like that, then oh, the glomeruli are already found. I don't have to do anything anymore. It looks very good already. So let's continue with this whole pipeline, basically almost the same thing. Okay, take the fine particles, take my converter to RGB, then you connect them up like that on top of the original image, and then see how well this behaves. Where was it? Oh, auto threshold 2D. Or did I connect something wrong? I have forgotten this 5000 limit. Better make a new fine particles today. And then it sees, when you check it, okay, my line thickness is a bit thick. Set it again to normal. Set the wrong, if I set like that, then okay. You see it hit many glomeruli, but it missed many too. Like this one here, they are all missing, and some are a bit too small as well. It's not what we want, because there was also a additional statistic that was captured in this data, is the general size of the kidney, because there was a hypothesis that the kidney size also changes. The glomeruli size also changes a bit in these nephrotic kidneys. And so we should not ideally modify the size of the glomeruli, because that could be important, this distribution. But I showed you yesterday already the how this can be handled for these specific blobs. I showed it even on you, for you. We need to basically do a feature extraction, so these glomeruli that we are actually interested in are really, really bright, and then everything else is dark. So this includes the kidney. The kidney itself, the tissues should be dark, only the glomeruli should be bright. And this morphological top hat that I showed to you yesterday was perfect for that. I just have to look up what the exact settings were, because they were based on the exact physical size of these glomeruli. So it doesn't work. And I have here also a comparison of these different thresholding methods. None of them work perfectly. We have to do a proper feature extraction first, or feature enhancement, so we can actually handle this properly. What was the settings? Oh no, I did not show what was the setting for it. So let's get rid of that here first, or let's keep it around but isolate it off. If you have like a set of nodes that you want to maybe keep around but do later something with it, you can click this isolation button here on the right hand side, isolate, then it will disconnect everything from it but keep internal connections alive. This is just a little convenience feature. You can just also disconnect them manually and then just keep them around. So let's do some pre-processing. So we have the top hat operation. There are multiple ones. Morphological top hat. And there are actually two top hats that I did not tell you about yesterday. There are white top hat and black top hat. That the black top hat looks for dark things on a bright background, and the white top hat does the opposite basically. So we're taking the white top hat because the glomeruli are still brighter than the background, connected up to the median filter. And then I will tell you again what is the setting. I have to remember that from memory. I think it was like 7, the radius, because if you calculated the pixel size of in this data from the physical size, it was like about 7. So let's try it out. I want to see it first before I make a box for you. Yes, looks good. Let's draw a thing again, a text box. And there's the radius is 7. You can play around with those, feel free to do that. So the white top hat has radius 7. And then let's try out auto thresholding, but just with a plain O2 auto threshold. So I'm gonna go here. I will also make a box for you, don't worry. Where we're gonna go and make it O2. So white top hat, important, not the black top hat, because this is the opposite operation. Looks for dark things on white background. And then method is O2, I think was the correct one for that one. Let's see if it works. It's always a bit. And then you see that, especially this area here already, where I know that was wrong, you see way more. You will never catch them all. It's a bit of a balance between finding noise versus finding actually signal. There's a method for that. It's a bit involved that captures even more, but it's a very complicated method to do it, and it involves multiple steps. So, and then when we have find particles 2D, we can then get. Don't forget to reconnect the original image if you isolated it, and we get way more now. As you see, you don't find all of them. You have to play around with the thresholding. Maybe use also one thresholding, but then this will connect find even more. As again, there's a method that can actually do this way more precise, but it's super involved in so many steps that then extracts it even more reliable. But it's good enough for this preview here, for this lecture. So we have that, but we sometimes find objects, as you can see, that are definitely not glomeruli. For example, we have here these elongated objects. These ones here, they are all not glomeruli, but we really only want glomeruli. Or here, like pixels that are definitively noise, they are way too small, and they should also be removed out before we continue with any statistics. And for that, we can do the same thing as before. We use the size filtering plus the same thing that ImageJ provides, a circularity filter as well. And I will make a box for you, and I have to first look up what was the size filter because it needs to be calibrated correctly. No, the min particle size is 0. Okay, I didn't have any size filter, but I had a circularity filter in there. There I make a box, and it's like min circ 0.7. And then when I run it again, then you see it filtered out at least these super long ones already. You see here, there were some that were detected here. This one was detected, it's all out. This one I think is not a glomerulus, so it's a bit too large. So there was a size filter as well in there. This needs to be maybe a bit calibrated, but it's good enough for now. Then, to have as a filtering setup. You can always play around with these values until it works out, or you can pre-calculate the values that make sense for the data. There was like an exercise in the last years where you actually had to, there was given the pixel size and the expected radius that you would see for these glomeruli in micrometers, and then you can calculate the size range that is acceptable for them, and then you would filter out the others that are not glomerulus, or you would basically have 90% glomeruli only, and then some missing. But this is good enough for our small pipeline to test these features out. Yes. Yeah, you see the intensity, you mean here when you see the measurements? Or what do you mean? Yes. Yes.
The mean.
Yes.
That is the threshold one, no?
Yes, because you are working on the thresholded image.
Yeah. What if I want to
yes.
the intensity, so the real one?
Yeah, and this is then something that is maybe a bit different from. So in ImageJ you would go to the image, so you would go back maybe to this one here, to the median filtered one that is denoised, and then apply the Roy manager's measurements there. In JIPipe there's a node for that, exactly that. It's called extract image statistics or image extract Roy statistics. They do both the same. Extract the Roy statistics maybe. There you give it Roy. And then there you give it a reference image that it actually uses to measure out the information. And this has the exact same measurements as ImageJ. And then there you get actually the proper values out as in ImageJ. But then it's all tracked down here and you don't have to do it automatic. So yeah, this is like, and later on you can also take these measurements. I don't know if I showed this or Sultan shows this. You can take them and then basically put them back in to the workflow back in, and then use this, for example, for better thresholding or to apply filtering on data. That there's a lot of flexibility. You can go from tables into something. JIPipe can apply its own filters and back and forth. There's a lot of back and forth sometimes in JIPipe that I can. We will not probably touch on that one, but for example, you have a whole filaments system where you can go ImageJ Roys to filaments that are natively filaments, so you can easily track lengths and do filters, and then, okay, I want it back to ROY, convert it back to ROY. And then you can come up with very elaborate algorithms that do crazy things, really, that are not so easy to be done in ImageJ at all, actually. Because here you have these systems in there. But we had to cut out the filaments a bit from the data that had filaments. Sultan, maybe, I don't know, maybe he shows one that uses the filament system in tomorrow. Where it's really elaborate back and forth translation and then taking measurements, put them back in using advanced filters. There you need also then a bit more better organized workflow than that one. This is getting full, especially on that screen. So what is actually the time? Oh, we have a bit time. So this one's done. 04 is it is advanced UI. Okay, this is actually a perfect one for that occasion where it's almost lunchtime. So few advanced UI features that you will use maybe in JIPipe, may or may not, like you will use them at some point. So pipeline organization, sharing workflows, user features that you will see. So you have already seen me for adding these annotations in there. They are now renamed. They're called Canvas nodes as a concept, but do the same thing. They allow you to draw boxes and arrows and text and even embed images. Please don't add too crazy large images into there, because this needs to be saved in some way to really help your eyes to find out what is going on in your pipeline. You can see this then with Sultan's pipelines a lot, where he then puts large boxes around sections that are supposed to handle something. For example, here, this is literally the kidney pipeline that I showed you. There's definitely a whole branch that is only for the tissue, so like an area around it with this text box here you can use, and then you say it's no text. And then one for glomeruli, you can make these arrows and so on. Useful, make use of it to increase the readability. And then there's a whole new concept, and then every time it is introduced, like everyone thinks, why should I use that? And then later on, they find it actually very useful, because it's called graph comparisons, and this is something for larger pipelines. So this is our current pipeline, approximately like that. And over time, these will grow a lot. So the more features you add more statistics, you add more adaptations to specific circumstances. Maybe you have to add some channel organization into it, so it does what you want. And then you get like this, I call this a noodle salad, because it's a gigantic thing that you cannot see anymore what it does. Real-world pipelines generally contain over 100 nodes, because they need to do a lot of data processing, not just drag in files, extract, for example, information from the names, extract information from metadata, reorder the channels, so the pipeline has a good time actually handling them, more elaborate pre-processing and interdependent segmentation, where it's like, okay, you segment first the part, but this part needs to be for another part, or you need the statistics from one segmentation to go to another. And these are getting, at some point, a lot for a single diagram. And this is why JIPipe has a system for that. It's called compartments. And you see it very prominently displayed at the top always as this compartments button, and then always it opens a tab called compartments, where you can access them because they're very important for you. When you open this compartments tab, it looks basically like a pipeline, a standard pipeline where you were working in the last hours. But it's a bit different. When you want to add nodes, you cannot add import image or anything into it. You can only add a few things. You can add graph compartment and annotations, or these canvas nodes into it, and nothing else. Because these things, they don't do themselves work. They are there to organize your pipeline into smaller sub-pipelines to know what is going on. So if I have here a standard setup for that would fit towards the glomeruli, you have basically a pipeline that takes care of, you have a part that basically takes care of the files, some part that takes care of the tissue, some part that takes care of the glomeruli. They are actually very separate from each other. They don't interact with each other in that way. And then when you set this up in this compartments editor, what you build up is something like this. You can actually make this such a render here with a tool in JIPipe to show these compartment contents. You have a file handling, loads files in, and then basically passes it to the output to be handled by another compartment. Then the tissue compartment, it takes the outputs from file handling, for example, the images that were loaded in, and then does whatever it does. The same with glomeruli. And this is a step that will at some point happen when your pipeline grows larger, that you start splitting it up into different compartments. So you start usually with, this is very specific to your workflow. There's no standard on how to do it. Your workflow, you know how it is separating itself in which parts. For this one, you can pre-create basically, for example, the file handling, the tissue and glomeruli, and then you can basically double-click them to go in. Let's do this here live. So I go here into the compartments. It's already open. If it isn't already open, then you can click this one here, and it switches into this tab because it's so important for the structure of your pipeline. You again have like this a quick explanation how to navigate everything and what it does in very short bullet points. I start adding compartments. There you can do the same thing. You can just add new things in. Currently we have only one compartment that's called analysis. When I double click it, we are back in here. JIPipe always has compartments. Just by default there's only one called analysis. And then let's keep this analysis one around a bit. And then let's call it file handling, or let's call it reference. Then I can make a new structure and later delete that one. And then okay, we make a new structure. We have some parts that are related to file handling. This is also the standard notation that Sultan uses, calling these ones file handling. You may or may not have like a pre-processing in there, but our pre-processing is literally only one node, so it can be done in file handling. Then graph compartment for the tissue, because our tissue analysis lives in there. And then we have a graph compartment that takes care of the glomeruli. And then how do we connect them up? They are by default like not connectable to other compartments. You see here, there's like a plus. Plus you will encounter always also in some other nodes, even in like normal mode, like where you make your own like functional workflows. Plus means you can make custom outputs or inputs. Depends on the node how they are set up. And for the file, for our case here, one output is enough. We don't have so much data that flies around, but theoretically you can make a lot of different outputs that are of interest. And these outputs bundle basically data. You will see it now when I add them. So let's add an output to all of them. Just click the plus and then stay with the default until all of them have an output and then look like that. Just click the plus and then just stay with the default. Later on, when you make larger pipelines that are more involved, then you will make like generally more outputs that are a bit more focused on a specific thing. Otherwise, you get, I call these a brick of death. It's basically one large output that has everything in this way. They're literally as the size of the screen and width. So let's not do this. And then what happens is, when you click, for example, double click the file handling, is you have only one node, and this is the output node. This is the one, an interface that tells JIPipe this data is basically the output of our file handling step. And this should go out and should be visible to the other steps that follow the file handling. So let it put here, and then let's already connect them up a bit. So our file handling, we need basically the file handling outputs, which will be like the files, the pre-processed image, because you have such a small field pre-processing. We connect this up, similar to how everything else is connected. Very straightforward branching. When you check now the tissue and the glomeruli, and you see there is something coming in from on top. Yeah, when you drag this out, this is really indicating you this is coming from above, that comes in from outside this area here. While the file handling itself, when you go there, there is something going out that goes down the pipeline, down the flow. And when you follow this one, basically, when you double click it, it shows you can go to tissue or to glomeruli, because this is where this ends up, this output. So let's organize it. It's a bit of concept to get used to, but then later on you will absolutely need to use this for organizing things. It's also part of the exercise too, I can already tell you. So we have here file handling. Let's organize it a bit into it. So we have definitively this one and this one. These are definitively file handling operations. They are we are importing images here, not yet with anything crazy in addition. But we and you see, and we have here a median filter, which is our pre-processing. Theoretically, you could make it into its own compartment, but it's so small. It's like, no, let's leave it in file handling. We copy this out with copy nodes or Control-C, and then we put it in here. So, and then we have only these 3 steps in there, and now we want to pass them out into the results that we care about. We want to pass those into the other functional units, basically. And what we care about is, first of all, the raw image, this import image output here, because this one we draw always our visualization on. So I'm dragging it into the plus. You can do it like that. It will pick automatically the correct types. And then it will pick out that there is an image JImage. And then we call it raw. And then you see it made it adapted itself, that it's an input and output at the same time. When you check now here in our tissue compartment, this one adapted too, because it is the same thing. It comes in from outside through this interface. Now we have access from inside the tissue compartment to the raw image that was generated here in file handling.
Paste those 3 nodes to the file handling.
You can just right-click copy nodes, and then you can right-click paste nodes. And then we didn't need also the raw images, but also we can do the pre-processing here, because it's literally just a median filter. And maybe the reference one that I provided you does it a bit differently, but let's do it like that. You can, because it bundles the output, it's like an interface, you can put as many outputs as you want. So this one I called pre-processed, because it's our pre-processed image. And then imagine if you at some point want an enhanced pre-processing with a bit more nodes in there, you just add them in here or replace it or change it. And the tissue and the glomeruli, they don't care about that at all, because it's basically the same interface. You can run these interface nodes. There are also just normal nodes that you can run. Oh, okay, I switched out the kidney.tif. I have to replace it. This can sometimes happen when you copy nodes. Where was this one? Kidney basic, kidney.tif. So when it complains that the file is missing, just load it back in or drag it back in. This can sometimes happen. And then we have the same thing. We have the raw image. You can look at it. Wow, it's the raw image. You have the pre-processed image. You can also look at it. It's the pre-processed image. Looks not much different. because you have such a large image. Let me save the project before I regretting it. This is 04, I think. And then they are passed through. And then we have still things to do here in our reference set. Then we have the whole tissue thing that goes on. Okay, then we just take the whole tissue branch of it, copy nodes, and I'm pasting it into here. This output we can use later. Paste it in. It will keep the interconnections, but then it loses all the others that are not directly connectable. And what are we thresholding? We are thresholding the pre-processed image, but we are drawing on top of the raw image. So maybe move this aside so it's visible which one is which. I have to make a redirect for that. I will make a redirect for that so it's visible. You can also, when the node, the slot order is a bit unoptimal, you can right click them and then you can here move them to the left, for example. And you can see it how it's organized. And it still works the same because it's just the same pipeline with the same settings, they're all copied. When I check here the morphological operation settings, it's all still saying 20 radius because we are basically working with code here. The output here we can leave alone for now, although we can say the measurements could be the output as well. And then we have some additional, we can do this afterwards. And then do the same thing as before with the glomeruli. We can even copy this to the Roy statistics that I made, copy it all into glomeruli, and then connect up what is correct. We are working on the pre-processed image, but we are drawing on top of the raw image. And then here it's a bit crossing, so we can move it to the left so it's not crossed anymore. It looks a bit nicer as well. And the reference image here is also not connected, so maybe move it to the left and then measure on the pre-processed one. So this can still a bit up to you to organize them so they are easily visible what is going on. There will be also edit like customization for where you can recolor these edges, but it's the next feature after the main feature now is implemented. This will come in also in 6.0 where you can right click and recolor them so you can follow them better. But when you click these nodes, then the color is selected automatically so you can differentiate where they come from and where they go through. And let's try it out. With cache intermediate results, it's such a small data set, still works perfectly fine. And see, finds all the glomeruli or many of them. It's not perfect, this algorithm, but it's organized into smaller pipelines that do specific tasks only. Instead of this thing, you can imagine this is growing large. Let me also copy the these annotations over. They are also just nodes, they are just different nodes. Reference, this goes into tissue. This needs to go into edit mode, yes. And then the glomeruli, we have the exact same thing. And then we paste it here. And then we have also the annotations going on in the pipeline. But then it's now 3 little pipelines instead of 1 large pipeline. You see, this is already there's such a small workload. This can go a lot, and then this one is way more handleable. And then when you get a new pipeline, you start usually here at the compartments, and then you check, okay, what is the general structure of it? What is going on here? You have something that is working with the files, something that's working with the tissue, and something working with the glomeruli. Maybe we're not interested in the details; they are just there already. And we can achieve actually the that you don't even have to touch this compartments view at all or go in by double clicking them to get your results out. You can actually do, we are almost there, like 90% there, to have something that you can just run all from this control center project overview. And there's a reason why I asked you to create these outputs here, because you can just also say, okay, what is the final output of our glomeruli analysis? Okay, this is here the visualization that we get out, so we can see what it did. Then we have, have these measurements, and we have even these improved measurements, and we can see the actual real brightnesses from the original from the raw image. And draw this in, call it measurements as well. And these are then outputs. They are not to be used in another algorithm because we are done. But you will see in a minute what it will do when I'm done with the tissue, doing the same thing. I'm in this mode here with the editing. I'm having again a visualization. So you can name them freely however you want. You have the full freedom there. There are some rules regarding the names, but it will complain if it's not a valid name. And then measurements again. They are the general output of this analysis here and done with the tissue and glomeruli respectively. And then you can go to the compartments when you to the compartments overview. They have also a play button here for specific reasons, because this play button here is connected directly to these outputs. This one is directly connected to that one, and this one here, when you play or run update cache on that one, it's connected to that one here. And when I run them, for example, the tissue analysis, you can run it directly here from this compartments graph, and you get your visualization and measurements directly here in this overview. You don't even have to go in to the actual pipeline. This is why it's recommended to use this output smartly to do this. And then even more is when you go to the project overview, this one also sees the outputs, and you don't even have to touch any diagram at all, which is very, very good for reviewers who just want to run your thing. Just write in a description here, I want to run the compartments. And then, for example, I want to see the glomeruli output results, show the results. Yes. And it runs directly from this view, and then they can look at it directly from here. They don't even have to touch anything of your workflow that you made. And then they can look at the measurements and do whatever, save them out as an Excel file, which can be done automatically as well. And it has here also recommendations on what you should do to make your project better. For example, write a description and then set a license. Ensure that all the compartments have outputs for you, and so on. So this is then a convenience feature that then also makes it easy for you to distribute the pipeline that you made to others, and for you to reuse other people's pipelines that they made if they properly set them up for you. And then combine this with the parameters and user path that I showed to you as well. This can be then full control center here with, you can do everything basically with this pipeline. So quickly let's check. I have basically made an explanation. You can go again through all of that. Someone gets a call. This is all explained again in the explanation here, how to do everything, how to create these slots, how to run them from this view, except this project overview. And then it's anyway 12, and then this is basically a new subtopic. Then I think we can do a break for 2 hours, and this is then anyway just a UI feature for the next. Okay. So as a side note about these plus things, because you will encounter them everywhere, there are some nodes that have these customizable slots where you can add custom ones. And if you just click the plus, then you first have to select from like these about 50 data types what is the correct one. If you, for example, want a plot to go out to there, or a plot to go in, then you have to choose, I want a plot. If you just give it, if you choose the wrong one, it will not accept that. For example, you don't have to repeat this after me. For example, I choose here something that will not eat an image. For example, this form data. If I drop an image in there, it will say I cannot convert it into a form. The JIPipe will always try to convert the data over to the correct data type for you, but if there is no solution, then it will say, no, I cannot do anything with that. What I always suggest is when you move things out through the pipeline with this system of output slots, you drag the data that you want to get out directly to the plus. So then it will auto-select the correct one on the left side that is appropriate for what you want to go out. Otherwise, you have to search through that list here manually. That's a bit inconvenient. So back to a bit of theoretical, yes?
In theory, if one wants to use a method which you cannot code, you have written yourself into.
Yes, multiple actually. You can use Python code in 2 different flavors. So first of all, pure standard C Python. So it will run a Python script literally in a separate Python environment and then collect the outputs. Then you can run Jython, which is like embedded Python inside ImageJ. You can do the same thing in ImageJ, and there you will stay within Java, and you are limited by Jython's restrictions and Java's restrictions, but it's like it doesn't need to save out the data first, and then you use JIPipe's own Java internal API. And then you can also use ImageJ macros as well. There's a dedicated node for that you can call upon your ImageJ macros. You have to adhere to a specific structure, so JIPipe can find them and ImageJ can find them. But this is also one solution. And of course, then when you use macros, it's like the last resort because you need to open a window and then the window can be worked on. This is one solution. And you can use also R scripts as well for statistics. And JIPipe takes care of the Python and R for you, unless you point it towards a R version or Python version that you want custom used. So, continuing with the UI and so on, and some concepts. So you can also organize if you have a set of nodes that belong together and then they form a very specific function that you just want to put into one custom node, you can form a group node that will just contain them inside. You just select the nodes that you want to be grouped up, then you click the group option, and then you will receive an automatically generated group that encapsulates those nodes inside. You can also add the group node yourself through the add node panel, and then you can completely set up the inputs and outputs where you use like similar to how the compartments are passed through, use those group input, group output nodes to pass data between the group. There's a difference in their functionality between group nodes and compartments. It's really group nodes used only for like small reusable functions that you can copy everywhere yourself. It's basically code that is done and you will not edit anymore. Then while compartments are just a structural organization system for your whole pipeline, you can nest groups into each other, into any hierarchy. Compartments are a top level hierarchy that is there for you to have a general system for anyone to look at the structure of the pipeline. Group nodes have an important limitation that they do not allow to be run update cache inside. This has some technical reason that they do not belong to the same pipeline technically internally, while compartments, of course, you have seen run them. With group nodes, you can also do easy iteration. So if you expect something that the group will, where you need to split up and a workload into multiple iterations, and then only keep this one iteration in memory. You can use groups like that very easily. For compartments, the current system is using a partition system, but it will be it's anyway rarely used, and then now when the memory thing is in at some point, then you rarely need iteration and grouping for JIPipe because then it takes care of your memory. The groups are easily shareable. You can just copy them. They are just nodes. While compartments themselves you can share technically, but you need to sometimes reconnect everything. This just comes from the technical point how they work internally. And then you can also run them easily from project view. These compartments as automatically a entry created for group nodes. You need to add them to a so-called run set where you can add custom nodes into this project overview to be shown to like someone who wants to use your pipeline. Then sharing your workflows. There are some standard techniques that you can use to share your workflows easily or parts of them. One way is actually the very common used one. When you just copy your nodes with right-click copy node or Control-C, this is literally just a text that comes out of that describes the node in its entirety, including its parameters. And then you can paste this text in any other JIPipe pipeline, so you can just send this text around or send it via chat. Many options there. Then you can also create so-called node templates. This allows you, when you have configured one or multiple nodes, basically save them into a custom library that you can just reuse everywhere. So there are some common ones that were built up over time that Sultan will provide you, I think, that are very useful, like standard operations that you don't want to drag together all over again. Just make a node template, store it in there, and then you can just just drag it out of this template library. To create one, you can click the appropriate button in the right-click menu or in this little context window thing that is not at the top anymore mostly, but more moved to the side of it. There, it asks you about the name, and you can put the descriptions there and so on. And then it will appear inside a dedicated panel called templates with a star icon. And you can then use this template view exactly how you use the node panels. You can drag them out, you can double click them, and then you can also export them out and import them from a file using the template menu settings, menu configuration manager. Then the project overview, I have mentioned this always a bit before. Okay, I get confused here because I didn't update the title. So regarding project sharing, there is a new publish menu that is in JIPipe 6 only. So if you have JIPipe 5, then it is not there. This will allow you to create a so-called row crate. A row crate is a standard file format or exchange format that follows FAIR principles. It's one of the fair digital object implementations, and JIPipe gained this ability in the being a part of the NHDI for bioimage. We really want to promote that. You can click this button, create row crate, and it will go through with you with an assistant to make your project ready to be used, to be really exported as a single zip file that contains everything, including the data, with all the information that row crates really need. And you need to provide a few, like you need to properly set up the authors, you need to ensure that the data is formatted in a specific way. You need to have descriptions. The system will warn you about if there is something missing in your project, and if this is the case, then it will allow you to export a zip file. It's very easy and very quick to do one, and then you can not only export them in repositories like Figshare or Zenodo, but theoretically Workflow Hub should also support it. It supports this full standard of workflow row crate that is made by them. So one way to publish it and have a compact zip. What I recommend is, if you want it for a review or something, then make a small data set that you can run quickly on a low-end PC for testing purposes. This one you put into a row crate, and then when you use these project user directories feature, then later on someone who wants to run the whole pipeline, you can just redirect it to the full data set instead of the small test data set. JIPipe can load these row crates in directly. There's the option given through the project menu or the getting started pages. There you can just select it. And then regarding to make this project usable for people, there is this project overview interface that is you can reach by clicking this project button at the top. There you can add all kinds of information for the project. You can give it a title, you can add the authors. If there were some people missing, you can even add acknowledgements and other citations into the metadata that JIPipe carries within the project. A comment for publications, write a proper description of how to use your project, what inputs it accepts, and so on. Below these descriptions, there are, as you have seen, like all the compartments that are automatically tracked in this interface, including this run sets feature, where you can just basically add nodes, custom nodes to be run together. Like, for example, train, cell post model, and then you don't have to make a compartment. And then on the right-hand side, there is a set of parameters for this overview. There you can either make global parameters that are defined within this view, and then you can use them in specific places within your project, or you can take parameters out of the project and from some node and then put it into this list here, so people can change them very quickly. And then, of course, this user path, which is a separate system from that. By default, it's empty, and as mentioned before, you can put like directories and paths, reference parameters, global parameters as well. And this one I showed you again already how to use this global directory system, how you can define them, and then how you can put this folder into your project to be used by some operations, for example, listing all TIFF files in the directory that is set through this interface. You can then also reference parameters. I can just show this rather live. For example, I want to make the circularity of these glomeruli as a parameter. So this one here, this mean particle circularity. And I do not want to hunt down always this node in the list somewhere, but I wanted to make it accessible through the project itself. So I just go here to project and I click references, and it expects you to basically make groups first, so I group them together. For example, I could make a group, empty one that is called glomeruli filtering, and then I add to the group a reference. And then I have a whole list of all nodes that are inside the whole pipeline, and pick out here from the fine particles 2D which one was that? It was min circularity. Max particle, min particle circularity. You can give it a custom name, or you can leave it. And when I save it, then you see here the circularity parameter. For example, I want to relax it a bit to 0.6. And then when I check again here, it changed here as well, because they are linked up internally with each other. In this way, you can make a whole set of parameters that are easily accessible through this interface. Also for you, like the most important ones, put some good information about the grouping, put some good description in there so you understand what is going on. And then you can quickly adapt your algorithms without looking for specific nodes. So exactly like that. You can just zoom in. And then there's also the ability to make global parameters, or they are very advanced. They need you to use them in a very specific way. You can just add them in a similar interface. You can choose basically the type and then give it a unique key and then use them everywhere. So I have here a small overview of a pipeline where I added all 3 of these different parameters. So I have here these directories. That is a separate system, or now they're called paths. And you can use them directly in specific nodes, like this project user directory node. And the exporter nodes have also direct access to them. And actually any node through a system called expressions, where you can find them directly and then do whatever with them. Then you have these project rights parameters or global parameters. They only exclusively accessible through this expression system that I explain later, don't worry. That will where you have to use it in a specific way, but then it's very powerful. And then references, you basically link up against a existing parameter. This is the most straightforward one, where you can customize also a bit. But for sometimes you want to calculate something out of a parameter, so then you go with this project right one, where then it's more dynamic than the current than these other solutions. Oh, I accidentally switched over. So then a few useful features that you will find as well in JIPipe. This first of all, we have here this project report generator. It moved a bit around. It's now in publish, and what it will do is it will create a text description of what your pipeline does in like bullet points. So it will collect information about what nodes you used in your project, the short description, what goes in, what goes out of the node, dependencies and things that you can cite that are related to that, and then per compartment and per node a description in bullet point or text that describes how the pipeline works. So theoretically, you could then, based on this text, completely cover the pipeline yourself. It will figure out which parameter you have changed yourself and which one is the default, and then just hide the default ones for you. Sometimes also useful if you give this to AI, because it can work better with these text descriptions than with the JIPipe pipelines, which are very large, to find some help. Then this isolation, I showed it to you already. We can isolate parts of the pipeline. This connects this part from the others as well. Very simple feature. Then there is also the rewiring node, where you, for example, have used all the time import image, but now you work more with CZI files, and you need to have access to the settings of the bioformats importer. But then you need to rewire like 10 connections or 5 connections, and it's super annoying. So you can use the rewire tool here to basically move them, drag them over to another node's output, and then it's reconnected, and then it's convenient this way. You can also now copy paste connections as well if you want, since JIPipe 6. So that's one alternative. Then duplication, when you have like a node that is selected, you can move your mouse where you want it copy to go, press Control D, duplicate it, and you can Control Shift D it to duplicate it together with the connection as well. So this way you can make very quickly parallel paths to explore some settings and keep the old one there. They are. Then you can also lock nodes if they are staying. If you want to keep them in place, you don't want to accidentally move them. Like L and Control L to lock and unlock them. It's also accessible through the right-click menu. So this was useful features. And then now we actually begin with the interesting thing, batch processing. So batch processing it's of course the goal of your image analysis pipeline to not only work on one image, but you want it to work on all your images, ideally automated, so you can start it and then you can leave it running all the time, come back like the next day or in a few hours, and then it's done. You don't have to do anything, and hopefully it's correct. The secret is actually that you work all the time batch processing while using JIPipe in this workshop, because JIPipe is by default always batch processing. So the zero cost style batch processing that JIPipe does is processing always multiple data at the same time in one go. We were working with these input and output slots. What they actually are is they are tables. Data tables are they called internally, and they have a specific structure. They have one column that contains basically the data, for example, the image or a table or a plot or a file path or something. And then you did not use this so much yet, but this will get important now, and metadata columns that are attached to it. For example, we have here two images that are within such a table structure, an axolotl and a duck, and these images are not there by themselves. They are organized in a table that has one column, #animal, that says which kind of animal that is. This is basically one of those ways how JIPipe works. So if you give this table to JIPipe's auto threshold 2D to process, what it will do, it will process both images and then apply the auto threshold. And very important, it will preserve the annotations, the text annotations that are attached to each row. It will just basically exchange the data in its most basic form. So you have this one-to-one correspondence. You see it even when you go to auto threshold 2D. When you right-click the node, okay, it's a one-to-many processing. It's like a one-to-one, one-to-n correspondence that it uses. So, and because of the fact that we keep our annotations always along, this is the default case for all these nodes, unless you configure them to not to. And there are some special cases when you have multiple things coming in, you will see them. This means when you take your image file in the beginning and then annotate it already with the correct information to know what kind of image this is, which is maybe, for example, the original file it came from, JIPipe will automatically propagate this information down your pipeline, and then later on, when you are here in a very late step, like 100 nodes down, you will still know from which image it came from, because this annotation you added very early in the step. This is basically how you now do batch processing in JIPipe. So I hope you did not delete the or close the project that has the blobs here, because you need it now again. If you did, then just reopen, which one was it? It was it 02, I think. I have to look myself if it's the 02 lecture. Let's just go with blob single here, and then yes, let's replace it, and then it looks like that. So it's in. Where's my editor thing? Notepad. It's in this folder. It's O2 blobs single, because this is the one that runs single blob analysis. I cannot pin this to top. Let me run it if it works. Yes. This is the one. If you accidentally closed the blobs one that you were working on, maybe let's make one annotation. So, and that's here. So we are now making it into a batch processing workflow, and I will show you how. And for that, we go into not blobs single, we go into batch processing blobs, and there you see a folder. It's called raw, and there are multiple of those images inside. 4. It's actually just the one image, and I split it up into 4 parts, but it's the thought that counts. So if I take them, all of them at once, and then I drag them in, then I get also a file list, but it doesn't say anymore the name at the bottom, because it is now multiple files at once. So let me also make a edit to the annotation, so then you have a reference. At image, this was raw. Is this one here. And then now what we're gonna do is we do not connect the blobs anymore. We disconnect it, and then instead connect the file list, which has multiple in there. And then that's it. We're now doing batch processing. So let's run it up to find particles 2D, because this is like the last step before that. So run it up to here only. And then you see we have 4 voice sets, we have 4 table measurements. If we go back in the hierarchy, if you do cache intermediate results, you have 4 segmentations and 4 pre-processed images and 4 images that go in. And then they're all there. So we converted it into a batch processing workflow now that runs multiple images. That's that easy, although there has one thing that you need to take care of in this regard. No, you just it depends on how the image layout is done. If you have some images have where you have the channels in separate files. Sometimes you have the channels in one file and you split them off with a split channel splitter. But the system that I will show you now, it will help JIPipe match up what channels belong together with each other. You'll see it in 1 minute why it is yet incomplete. It's a bit incomplete. No, it depends on your input layout, because in the end, the data is how it is saved. It depends on how the file layout is structured, how you handle that. I've seen data where, for example, the channel is separate. For example, you have a subfolder that contains the channel 1, other subfolder that contains channel 2, and they all correspond. But then sometimes you have images that have all channels in one. The file contains all the channels, and then if you want to look at a specific channel, then you do a channel splitter in JIPipe. It will, like in ImageJ, where you run the split channels command. JIPipe has the same thing. It's quite common actually. Soltan has like a big block that can do a lot of that automatically for you. So yeah, this one, but this is incomplete bit. I show to you again. So you drag instead the multiple things in there and just reconnect it up. Then we have 4 images that are then now handled, and we are happy. And where is the catch? If we run the convert ROI to RGB node, then we suddenly get 16 images out here. And there is a problem. The cause behind this is because JIPipe doesn't know at this point what belongs together. But we are gonna resolve that, don't worry. So we have here 16. So we have 16 rows and equals 4 equals 16. So if we disassemble this analysis project, and then I check here all the intermediate results. So, okay, we load 4 images in. Then we go to the next step, median filter. It median filters 4 images, still good. Then we auto threshold 4 images, still good. And then we find particles. We still have we find particles and 4 images good. Suddenly we have 16, which equals that 4 equals 16. Mathematics has been wrong all the time. And if you encounter error, something like this, you check the specific tab now. So you go to the node that offends you, like this one that suddenly makes 16 outputs. You go not to the results, you go to the inputs tab here. And this one will showcase for you how JIPipe matches data against each other. So it basically gives you a preview what it will do when you run the algorithm. It in the newer versions like 6, it has like a separate tab for inputs versus preview. In the 5 version, it will be in like one long interface. And then you see here what the correspondences between the inputs. Like we have here the ROI input, and then we see here what goes into ROI. We have image that and as well here, and then see where they basically get assigned. That's actually the explanation. We can also get a preview of the individual steps that it will do, like how many times will the convert ROI to RGB be repeated on which inputs. And you see then here, when we look at it, let me close the documentation so I have a bit more space, that when you look at it closer, that here is the matchup okay, but then you see that the ROI and the image stopped getting matched up until we're like we have only 4 that actually correctly match up with each other in the end. So, and why is that? So this is the old interface. I forgot to update the slides. If you look at this inputs preview thing, then what these blue numbers mean is what there is basically each ROI is assigned to multiple steps. So it's basically reused 4 times actually, while each image is also being reused 4 times. Actually, we want each image and each ROI to be used only once. So there is a single iteration step assigned to that, to each one. We'll see this then soon when we fix this. And then in the preview step, we see that there's suddenly then 16 because they are assigned multiple times. And most of them are wrong because they're just wrong. And this is then now something that you have to take care of when you are doing your data management with JIPipe. You have to guide the iteration. For example, I have here a case with axolotl images, like as 3 channels, 3 different channels, and I want to run another node that combines multiple inputs. And I tell it to please merge these channels so I have one image that is multi-channel. The computer does not understand that the first row is a duck, axolotl, and the second row is a duck. It doesn't see this. Computers are dumb, and even AI extremely dumb still, and cannot understand everything. So you don't trust it. You have to tell it what is what. And the solution is you annotate the information to the data, so it knows what is a duck here, and what is an axolotl. Then the system with the following inputs can then actually know what belongs together. So this is basically one of these input tables that would be received from merge channels for this merge process that would actually work properly. We have the axolotl with the annotation that it is an axolotl and for each single channel. And then later the node can then look at this annotation and identify, okay, this is the image that belongs to that other image, because they can be also in any order. So there's a simple way to do this. As a simplest case, you just basically take the file name that the image was loaded from as the main discriminator from what the image is what. And then, for example, here I have the folder that has all these blobs 0, blobs 1, blobs 2, blobs 3, and then we annotate this information to the data so it stays there and it just gets propagated to the system. And then later on, when we have something that needs multiple information, it can merge it together. And it's very simple to do. I show it to you. We take here everything, I move it a bit down to make a bit space. Then I'm gonna delete this single connection here. You can also click them and then press the delete button. And there is one specific node, the ones from the annotation series, they are distinctly purple in hue, because they're important for that. And it's called annotate with, it was annotate. It's called add path. Here it was called add path to annotations. I renamed it at some point. So it's annotate with file directory name. This was like renamed like 5 times already, this node, because it's so important. And it's reachable under multiple alias versions. And then we connect it in between these. So if I run this node here, it is pre-configured by default already to take basically what comes in. It takes paths and then add an additional information to it, as an additional information, the file name of whatever goes in there. Like here it's blobs 1, blobs 2, blobs 3, blobs 4.png, and it just adds this information into a column, into this output table that we are working in. And as this information gets propagated through the pipeline, you can run it here up to the cache find particles. You see that each one still has this information plus this threshold here for these older pipelines. The threshold is still added by the auto threshold 2D. You may or may not have the threshold, depends on which pipeline you loaded. And we still then, even if we do not see what is going on here, from which file it is, if we check the annotations, we still know it comes from blobs 1. And JIPipe knows that too. Because then we check here the convert ROY to RGB inputs tab. You see that now it looks a bit different. The numbers are not anymore blue. They are colored in a specific way to highlight to you, okay, this has a single image. This ROY here has a single image that it matches to. That is in the first step basically of what we're gonna do next when we run it. And it matches against the dataset annotation with this hash. That's why it's in highlighted green. And then when you check a preview, then we see we have only 4 steps. And when we check the ROYs and the image, they match up automatically with each other because they came from the same image originally. And then when we run it, actually, then we have 4 images, and you see how it all matched up perfectly how we want, and no more 16 images as well. And this is the very basics of this annotation system, how to add information to data that gets propagated through. It has some things that you need to know about it. The default of this node is it generates an annotation hash data set. You can change that, of course. however you want. Depends. Sometimes you have to make like cascades or multiple annotations step by step. Maybe you have a folder with subfolders, so you add the subfolder information first and then add more. Then you search for the files and then add for each file also the file's name into it. And then this one I showed to you. The default behavior is that JIPipe looks at the annotation columns that begin with a hash. This is its really default behavior. It's like, because you may have annotations that are not considered important, they may for the data management, but maybe interesting information that you need for statistics or for some other algorithms, but JIPipe should not use it to distinguish data with each other. So the default system, it's just was developed over time, is that if you have a hash at the beginning of the column, then JIPipe considers it important by default and then uses that to differentiate the data and leave the other annotations all alone and don't look at them. You can change the grouping behavior here. There's a setting in there in this input manager. It's here, and there you can choose from different kinds of ways how it takes apart the data and distinguishes which ones belong together. Sometimes you will end up using this custom setting here where you then tell it, okay, please go with those specific columns to distinguish the data. That can be used, but I think Sultan uses that for some things and he can show you some tasks. I don't know if he will show some. But it's like the very basic of that. And it works now when we have solved our issue. And the same principle we can apply to the kidney processing too. Hopefully you did not close it as well. So I have it still open. Everything is wobbling here. So this is the kidney processing that I had before. And then that's why it's good to have a file handling compartment where there's everything in there. So currently we have here this kidney.tif as the single input that goes in. Do that. Let's move a bit apart. And then let's look for the other kidneys that I have somewhere in this folder. Yeah, I feel like this. Please do not take the kidney 3D20 sizes. It really takes few hundred megabytes in memory. So I'm specifically taking the kidney without number and then 2, 3, 4, 5, 6, 7 and just dragging them in. Okay, now it left me. Then do the same thing as before. I add path to annotations or whatever this node is called, annotate with file directory name. Then drag it in, done. We now have batch processing. It will work everywhere. And I can prove that. I can go to my compartments here or the overview. I want the tissue information, and then now it will automatically, when you see like the status, it will run through 7 things. You get 7 visualizations, you get 7 measurements out. The same with the glomeruli. Then it will get 7 glomeruli things, 7 glomeruli measurements. You can browse to them. So this is why JIPipe has its own viewer, because here, when you work with multiple data, you can go with this thing here. There's also a key binding. It's control these keyboard up-down keys. Then you can just browse quickly through your data and then look if your algorithm worked properly. It actually did not find all the glomeruli. So there's a need for enhancement with the algorithm, maybe a bit more lenient thresholding algorithm that can be used. This way you can develop your pipeline very quickly, give it few data to test out if it works well later on. When you're confident that it works really good, then you can give it the full data set and let it run fully through it, and then you have your results. And this was very simple, just 2 additions. Actually, just one. This singular node here. And then you can go at any point in between. For example, if I do the cache intermediate results, then it will keep all the intermediates. Be careful with your memory when you do cache intermediate results. You'll see it here in climbing. Then I can go at any intermediate step and then see all the intermediate results for all of them, and this stacks up very quickly in memory, so be careful with that until the JIPipe 6 version that is really final is out. Then this one will take care of your memory, offload it to your hard drive. These are basically the basics. You can then also do some nice things like this data trace. For example, I ran this through here, and then I had this once actually with a data set where I was not happy with the results, why this look weird. Example, which one was that one that looked particularly weird? Like, okay, what is wrong here? Then I can, okay, I can start it actually from here as well.
These are the copies of your laptop borrowing agreement. We copied it for you, so if you got your copy.
So you can either click here next to the update cache the trace button, or you can right click them here in the table and trace them. And what it will show you is basically how the data was produced. Okay, this icon still must be fixed, but then you can look through a table and then see the provenance of the data, how it was formed from a file to whatever you're looking at. Okay, now it's capturing some additional ones because you have a merging node, but there you can really review also why suddenly is your data weird, and you can hunt down why instead of as an alternative tool. So let's save that. And it's also explained again in the lecture materials as well. So then now we go to next topic complex. It's now getting a bit more involved. It's path processing and exporting data, because these all you need really to get a bit of grasp on to understand how we are continuing. So what we want to do is now something that works with paths. Especially we want in the end to export our data into, for example, images. We want Excel tables out of our workflow that we can then further look at. We can put into Excel and analyze further with its tools, etc. So far, we dragged basically the input files directly into it. So I dragged the 7 kidney files into it, or I dragged the 4 blobs files into it. But this is not very flexible. You have to always go into this node and then always switch out the node or add new paths. It's very inflexible. But JIPipe, fortunately, has actually a lot of path processing nodes that that help you with that, and also can handle like more complex arrangements. So for example, where you have subdirectories that contain information, where you get the ability to filter out data that you are not interested in, or where you can handle then automatically duplicate names. For example, here this control1.tif is the same name, so we would need to take also the subdirectory name into consideration for the further processing. And for that, you have to really remember that we are working with paths, so location files, location information, a text where the file is actually located. This means we can work with it and process with it. For example, we can use JIPipe's path processing system to extract information out. Okay, somehow the build-up is a bit broken. For example, this one here, this add path annotations or whatever it's called now, it extracted this information here, the border somehow wrong. It extracted the file name from that path out and put it into annotations. You can also just process the path and then go one directory back. So I can get back this parent directory from its file, although it's rarely used, this node, or very commonly used, where you list subdirectories or list the files within a path. Well, for example, you want to list all TIFF files, all CZI files, or LIF files inside a subfolder, or where you want to list first from your input, your main input folder, all the subdirectories, and then further investigate inside there. And then also a general filter node where you can filter out specific data that is not of interest for you. For example, you have data that's split up into maybe multiple scales, or it has some condition that you're not interested in. There you can filter it out using JIPipe's system. Then, fortunately, to test this, I actually have a test data set that you can use. I have to just look for it where it is. It's in this kidney exports. Yes, I found it. There's a folder raw inside, and this one actually has subfolders with different files in there. We have one, as shown, a file that has a duplicate name itself, and so we should not forget there's a subfolder. So instead of dropping the files in as is, let me isolate them. Control-Shift-I if you want a shortcut for this isolation. Move that here, you can maybe take it to the side. Instead of putting in all the files in there, I just give it the raw folder. Come on, Windows, hello, Windows does not like me. So I drop it manually. Hello, Windows. I just copy. I'm in the zip file. I'm not. I have opened the wrong one. Where is it? Where is it? It's in downloads. This one. Let's check data. And then kidney exports. I just dropped the raw in. And then when you run this one, it will basically be a path to the raw folder. Nothing else. You can open it or whatever. And what we are gonna do is now, because you have subfolders in there, instead of listing all files immediately, we systematically go through it. We go and list first the subfolders. So we go and use the node, list subfolders, which will basically explore whatever comes in and then expand it into subfolders. There will be 2 subfolders in this raw folder. We see that 2 folders are now explored. There are, when you look at the paths by double clicking them, you see there is one that's the control path and the one with the NTN condition from the original data set. And then, because we want to remember the subfolder where they come from originally, we are using now this annotate with a file or directory name, copying it and pasting it, but we give it a custom name. For example, it's often like a condition, and we still keep it with the hash because it's important for our data management that the condition is being properly tracked, which will then add into the results this condition. And as mentioned before, it will propagate further to the pipeline. It will stay there unless you modify it or it's being merged with some other same named one. And when we go and visit this directory, one of those, you see that there are these TIFF files in there that are all differently named. And how can we explore these automatically? Well, there's a conveniently named node, list files. And there are even pre-made ones that are already set to, pre-configured to only list TIFF files or PNG files, and then you can adapt them to your own file types. I'm going with that one because it has a specific syntax. List only TIFF files. if we don't list all only TIFF files, then it will also hit the when you go into the folder. It will see also the CSV file that you do not want to load as an image. And if I run it, then you see we have a lot of files now, 7 again, as the original input, but they are organized. And then this time we want to also remember the file name. So I copy that one here, which will make a hash dataset annotation. Let's see, slowly build it up. You see each file has then now a condition and a dataset attached to it. And this will be propagated by JIPipe through the whole pipeline for you. And I make some boxes, don't worry, so I can you can remember what I set there as a setting. So it makes this is condition, and then this one here is set to dataset. This stays the default. And we subsequently explored now the hierarchy, and you can go as deep as you want with that. Just stack them on top of each other, make some smart filters in there. You can also, for example, when you have ROI files that are maybe in a separate folder, just ensure that the annotations match up. JIPipe doesn't care; it looks only at the annotations. It doesn't need to be pre-organized. Like with some tools, you need to pre-organize the data into a correct structure. Of JIPipe doesn't care as long as it knows how the data is matched up with each other. And you see here each image has given a condition, and now that the control one image has a separate information that JIPipe can use in form of this condition to differentiate between them, it will work absolutely fine. And then you can also modify these annotations as well. There are specific nodes, I don't know if I will handle them, there where you can really modify them, extract specific information that you really care about, and write it into new annotations or overwrite them. So to really have a lot of control regarding how the data is organized. This is why it's really good to have a file handling compartment where you do all of these things with your data management. And the less standardized you save your data, that, for example, all channels are nicely ordered and the data naming is the same everywhere, the more work you have to do in organizing it from JIPipe's side. So name your data nicely, and then this compartment will be very small, and you have less weird processing to do when you want to load the image in. Then it's basically done. We have now fully batch processed workflow that will completely work fully through everything, and have our more advanced hierarchy of files that are properly organized. For example, let me run here this tissue output. Then you see here that the image, if you look at them in the viewer, there's always here this annotation panel. You can pop it up, and then you can see whatever annotation is attached to that as information. And this way you can leave it open and then see, okay, for control 1 and control looks good. And I can browse through it, and you see here there's like this one thing missing because this 5,000 pixels, the condition is maybe not good enough. And then I can see and check what this is going on here, and then I can modify the algorithm so it does not do it anymore, what I don't like. So let me show you again until everyone has caught up. This is our file handling compartment, and this is why compartmentalization is nice, because it's only that one that you're working with. Let me quickly check if I explain these expressions. Okay, we did all the same things. There are different filters as well. And then, okay, good that I explained. I will explain this soon, but I let everyone catch up first, that they have that set up. It should run through fully automatically. Just ensure when I run the images, import image, just check that you have the condition as a column in your table of data, and the data set is also a column, or name it how you want. You can also name it hash image, as long as JIPipe can distinguish it. It does not care about the naming at all. There are sometimes like more complex projects that will have like 5 different things that are tracked at the same time or more. Hmm?
So at the annotate which file directory do you write that in, or it's a node that
This one.
yes.
You set it here to condition. Let me copy that one. So if you're working with these annotations and you press escape, it switches between the where you can drag them around versus where you cannot drag them around. This makes it easier, but it's a very new feature and I need to get used to it myself. And then an output of the import image, or actually earlier one already would have a nice condition and data set. And then you can imagine when you track more information, you can also get these annotation from other sources. For example, the image parameters, you can get this from channels. When you split channels actually, then you can keep this channel information around in some form. You can also then later rename annotations. You can delete them, you can rename them. But there are a lot of possibilities of working with your data smartly, so it does what you want in the end. This one here. It's basically you say which info, so it takes the file name or directory name, and then you tell it where in which column of the table, of the Excel table to save. And then I call it condition. You have to type it in. So yeah, it's really important. You have to set this one here to condition, otherwise it will override it at a later point. Because it's really imperative that you tell JIPipe when it still has the information in its data about where at which condition folder it is. Please remember that information, otherwise it will just get lost when it flows through the pipeline and you start importing images. Jo. Gucken wir mal. So that is my next thing. So some people might have the issue that it won't work. You get a weird error, like null pointer, when you import things. And the differentiation between that is that your list files is not set up to filter only TIFF files, because I was evil and placed some CSV files in here, which are not TIFF files. So, but this is a realistic scenario. Sometimes you have XML or CSV or JSON files sitting down there. They were generated by someone, and you have to take care during your data management to better filter them out. You only want TIFF files. You only want CZI files, for example. And how this is done is I just opted with the lazy option, using this only list TIFF files, list files pre-configured node. You can find it. What it does here, it has an automated filter system inside to only pick out TIFF files from these inputs. Because when I turn this off, then I also get the null pointer exception when it tries to load a image. And you see here, when you scroll through the errors a bit, it tried to load a CSV file as an image, but it just isn't an image, it's a CSV file. So you will find here this only list TIFF files operation that has this here pre-configured inside, which I will add to it, just so you know that it exists. Let's size it a bit, and then change the font size a bit down. So it uses a string matching, glob matching for it. And this flows directly perfect. Yes, there are some questions. Sultan. Help, there was a question.
There was a question.
This goes in keep file if. This is actually the important thing that this comes pre-configured if you choose this only list TIFF files. And you can then easily adapt it to CZI files or PNG files or whatever files that you're interested in. But it's like a pre-configured one that you can use as a basis. You can even add more custom stuff in, and this is what I want to talk about now, the expression system. This is your main way of customizing what is going on with JIPipe. You will find them anywhere, in many different nodes in many different locations, basically hidden everywhere, because they allow you to provide a lot of control in this still limited compared to programming environment. So you will find them everywhere. For filtering, you use expressions for generating data, for customizing specific aspects. And they are indicated by parameters that look in a very specific way. They usually say always expression in there, and I have a big edit button where you can then open a PowerPoint style expression editor that helps you through a bit through what is available. They are also useful for filtering. Again, here's like sometimes they have an information where they exactly are applied. For example, you are filtering ROIs, and it says I'm filtering per each ROI. This operation is being executed. When you click this edit button, it will open this editor. It will help you validate if your mathematical expression is correct, and to list what is available as operations and as variables if JIPipe can infer them from somewhere. And what happens here with the CSV files that came in is that when you by default, when you just use the filter paths node without anything added to it, this filter expression is empty. It's basically defaulting to, okay, I'm not filtering anything. You have some basic standard filters like, okay, only files, only folders, and so on. And when you click edit, it looks like that. You can type it in. And then one expression, the very simple one that you can put in if you do not use the predefined one, is the name. For example, the file name. It should contain .tiff. It's not the perfect one, but it's mostly sufficient unless you have .tiff somewhere in some file names. And this tells JIPipe when it goes through the files to gather for the next step is please only take the ones that contains TIFF. Alternatives are string ends with TIFF, so must end with a TIFF extension, or this glob one. This is the one that is pre-configured, which is the most correct version of that. And over time, you learn how to handle these expression functions, especially when you learn to slowly customize your experience here, where you have a lot of functions there for logics and conversion to numbers and picking out specific parts and splitting them. It's very similar in style to PowerPoint style expressions, so this is intentional to be very similar to PowerPoint, not PowerPoint, how Excel does it. So you find the same rules basically regarding usage. This is the predefined one that you can use, but you can use others. So, and then our file handling looks like that, where it's properly working. And then really important that I forgot a bit to explain is you have to really set up this filter paths. Otherwise, it picks up your CSV file and tries to load them. And then it should work immediately when you have set this up. Let's close that and close that too. And then, for example, I want the glomeruli, okay, show the results, and then it runs through it, and then I have the glomeruli. Can check them in the visualization. I can pull up the annotations that through this panel. I can always look at them, what is annotated to the data, check it, see if it's good, and so on. So this works all immediately, because when you do the data management well, when you're very careful with the construction of your data set, here I called it experiment, but then here in the other I called it condition. JIPipe does not care at all about the naming of your variables. Then you have the data. And then what came already up multiple times, how do you now export this? In the end, you want files that you can browse through, that you can upload somewhere, or you can just save. Do not want to recalculate everything, or you want to process them with Excel, etc. And then we now coming to the exporting in JIPipe. There are two ways of exporting, and one is the older one, that is this automated export, and then the one that you will 100% always usually use for that is the manual export through specific nodes, because there you have actually the control mechanisms to do what you want exactly. So the automated export is run through this run command here, where you then choose whole project customize, and there it will basically, I will not show it for you because it's very rare case where you need to run that one. It will be able to run the pipeline in fully, and then JIPipe saves in its own format that that is usually less usable, has been discovered over the years to most people. But it is still in there, because it's still in there. And it uses a standardized format. You see here an example of how this format looks like. It has like a hierarchy where you have files that are organized in a specific way, but this is usually not what you want with it. You want rather to have the manual export through exporting nodes. And then what I suggest, depending on how much and how complicated your export process is, maybe you want elaborate visualizations and so on, you may or may not have some dedicated compartment for that, and then save it in there. Although I probably for this example don't need to make these compartments. I can just export it in the main compartments as well. Or let's think about that. Let's make compartments. I randomly decided that we will make compartments, and for that I take here my kidney project again, and then I'm adding into the scarf compartments two. One will be the tissue export. No, I just make one export compartment. Export results. Then you merge in basically both the glomeruli and the tissues outputs. This shows also how JIPipe can merge things, because this is something that is rare for these visual visual programming languages. You can actually merge things in JIPipe, because you can, because you're working with tables. It's basically merging the rows, and then I'm adding an output as well. And this compartment here, this new one, will be responsible for exporting what we created here with the tissue and glomeruli into files that we then have on hard drive. And then we can give to someone or look at it in Excel. So this is the setup. And when you look at these export results compartment, then you see that it receives multiple inputs actually. So it has this output. It's still there, and it both receives an output that comes from tissue, our visualization and measurements, and glomeruli, also visualization and measurements. And we now want to export them out into files using nodes. For example, I have here a goal, like what we want in the end. We want like the results folder, and then for each tissue, we want the visualization. With the here it's called experiment, but in the other pipeline it was called condition. And then the data set, so PNG for visualizations, the same for measurements. And then for glomeruli, we want basically the same thing as well. And it's quite straightforward to make. there are a whole set of exporter nodes that help you exporting the data. So again, back here, this is the compartment setup. Ensure that the export results compartment has both the tissue and the glomeruli going in and has an output made. Then we can trigger basically the export from outside through the compartment system. And then let's start with the tissue. And there are, when you go here through this export menu, when you right click it, you see all kinds of things like exporting 3D scenes, exporting images, exporting voice, tables. And we want to start with the visualization. Sounds good. Let's export an image, very plain export image node. And then we hook it up against the visualization input. And by default, JIPipe comes pre-configured with something that it will do. It will export into an automated generated file name somewhere into a folder that is temporarily created. This is what this file path does. This is basically telling JIPipe where it will go. And for that, I have to quickly check how I did it before. So this is the default thing with this path combined. We provided a data directory that it takes from somewhere and then an automatically generated file name. But we wanted maybe next to the project directory or a custom directory. Maybe project directory is a good first first candidate. Then we basically adapt this path that is in there to look similar to this. I will adapt one that is according to the condition. So let's export this image. Instead of path combining this is tissue, yes. We start with the project there. We can see this when you edit. Then you see here, for example, the project directory in the list. Project directory. And then what did I say? I want results as the next path component. You can also like plus them up like with mathematics, but this path combine is a bit safer. And then tissue, because you want to save the tissue. And then the file name that the tissue should have. And it shall be the condition, because I named it here condition, plus the data set. This you type into the system. I will press accept. It will also do a syntax check for you. And this is what you type in. And it will export the visualization as a PNG file for you. And when I run it, I leave this open so you can see. It reruns everything. Yes, PNG export is a bit slow, always. And I run it, and I am. Is this the one from today? Oh no, put it somewhere. So I have saved the project here in this root folder. Here in results, it made a folder tissue, and then for each tissue, it built up the file name based on the annotations we gathered first, which are the condition, so it replaces it, and then the dataset name, and it's accordingly named according to what came in, including this broken piece here. In this way, you can then smartly use the information you gathered, even information you gathered during statistics. For example, you can put statistics in there, like make classification or other information, and put it into the file name for your output. Just ensure that it's well chosen, this naming schema, so you don't accidentally overwrite anything. That's not what you want, and you've got some data lost. The best thing is when you figured out like here this schema, you can just copy it everywhere. It's always the same system everywhere. For example, if I take this export image, take it to the glomeruli, I duplicated it, then I just change it here from tissue to glomeruli, This will take care of that. Then I want to export my tables. Well, what I want to export a table, and I can choose even the format. For example, Excel, if you like Excel more. Then I just copy it because the naming is the same. It will create the extension itself, and then do the same here, glomeruli, and then this is why you have an output here. You can just say I want the exported files, and then you can just drag all the exported files in here, and then it's basically I can trigger this export for everything in one place. So you just adapt here this glomeruli and tissue accordingly, and then it triggers all the 4 nodes to do whatever they should do, and then I have everything exported. I keep open this expression here. And you see here, I have here my tissue measurements. I have here my glomeruli visualization and measurements as files directly there. I don't know why some of these Excel files are 0 kilobyte. Should not be like that. Why it is 0 kilobytes? Why? Because Windows has a bug. They are 150 kilobytes, but they show 0. Hello, Windows. They're not 0 kilobytes. When I double click them, then they suddenly update. And then I drag them all into the output, and then then you don't even have to go here and run the nodes manually. You can go into the projects overview and then run here the output basically of the glomeruli output of the let's refresh this for the export results output, which would trigger the export mode from them. Yeah, so it's a bit scary, these expressions, but they should not be terribly different from bit more advanced Excel. You gain a lot of flexibility by doing that, because then you can export it exactly as you want and not somehow. Or like, okay, this is a middle count. No, I want the file exactly there and not somehow something automated. If you're struggling with the syntax, use this edit tool. It will complain when you have wrong syntax. And yellow are always these variables that it will take from somewhere. For example, here it shows you that you have the data set and condition available as information, as well as the project directory. And quotation marks are these texts that are fixed in place, and blue are functions that do something. And don't worry, that's historically always the point where people struggle the most with that one. So let's add this one here too. Then it auto exports everything. It's just a common way. So just ensure that when you do try this, that it really shows here this information, this N21, indicating that, okay, I am merging all the tables into one thing, so into one file basically in the end. Otherwise, it will go through each table individually, which you can confirm through the inputs. Let me update the predecessor cache. So when I leave it at default, it will run 7 iteration steps, because this is what JIPipe does. It keeps the data apart by default. But we can tell JIPipe, no, please don't keep the data apart, merge it into one. And this is supported by all algorithms that do like this icon here, this little merging icon. And they allow you to do this n into 1 batching. There's examples. That's all what we did. And then we can also adapt it already to the project-wide directories to have it really flexible now. So far we have this raw and results directory defined inside our pipelines directly. But then it would be even nicer if we allow someone else who wants to use our pipeline to define their own directories, and then they can point it to a different raw inputs folder and say, okay, please put the results there. And it's, I showed you a bit about that already. It's not that hard actually to do. We go into the projects overview with this projects button. And then go, if it's here at the results mode, go to parameters, where I already have the circularity in. You don't need the circularity specifically. And then we are gonna add 2 user paths that then the user who is sitting here in this overview can use to point JIPipe towards inputs and outputs. So we're going to add a new input directory, open directory. I hate this Windows directory chooser. It's a kidney single, no toolbox, compartments, no exports. And this is going to be the raw directory. And we're calling this the inputs there or something, or inputs. You can name them how you want. You can have as many directories as you want. Ideally, you specify a role, because this is then useful for the raw grade export. We say specifically JIPipe, this is an input. It should exist as an input. And I can also give a description, all the inputs, hierarchy of the input files goes in here, and then it appears as a additional parameter where then the user can point it towards something else. Then we add a new one. This is where all the outputs will go. It never remembers where it is. Where it is downloads here. Export. Before that, it was this results folder, but maybe make a new folder and maybe call it here results, but with directories. You can choose whatever you want, and then we call it the outputs there. In the description, it's gonna be all outputs will be written here, and a role is being an output because stuff goes out there. And then when someone wants to run their pipeline, a reviewer, someone else you want to give them, just tell them or write in the description. Here the inputs there point towards an input, must be structured like that. Outputs there point towards where your outputs will go. JIPipe will create all directories automatically, you have probably noticed. And then now we hook up the pipeline to utilize those. And this is not that hard. We have anyway almost like 90% ready of this pipeline that can do that. First begin with the inputs and file handling. We provide here this folder list as input, this raw folder. And instead of that, we use a project directory. So let's search for it. Project user directory. Add to graph. And this one we have to configure with the correct key, as it highlights here with this information icon, orange warning icon. And I called it, I think, inputs there. It will complain if it's wrong. Is it? Yes, it's correct. And it points to the raw directory. And we can get rid of that one here. and replace it with the project user path. Just ensure that this key really is exactly the same as specified. You can review the keys by going to the project overview, user path, and then configure, and then there you will see all the information. Why doesn't it save the role? To check that. Where you see here the key inputs there. You can also give it a name like inputs directory and outputs directory. And it did not save some. I have to write that down to fix that. Then it works like that already for the inputs. So it takes it from that folder. And then the outputs, we have to do one small adaptation to the exporter nodes to actually use this new folder. Before that, we have defined that we use the projects directory as our root, where we start, and then we go into another directory, results, and then tissue, and then generate the file name. Instead of that, we are using the project directory, and this has a specific way how you access it, which I forget myself. So I use this editor thing here, which allows me to first of all remove the directory, just we leave the tissue and so on there, because at this point we know where the output will go. And then we can search for this one here, outputs. And there's basically a variable that we can just put directly in. So project data, the outputs there, insert into the diagram, into the formula. It's a bit long, but it doesn't matter because you have to only do it once per exporter. And I'm gonna copy that one and then just adapt that. Just use the editor to get the initial value, then the editor can copy paste it. And then adapt all the other outputs too. So it uses this new system. Yes, it's a bit involved to set this up, but then you have the full power behind it, and then at some point it's anyway useful when you publish your pipeline that someone else can easily use this. And, you can tell them, okay, please go there, and then point it towards the input and output that you want. And I'm not gonna show you in the box because you configured this yourself how the names are. So you have to adapt it box accordingly. And then when I run now this output here, merge everything, run all that I made, it will run through, and then I should see that it will make here the folder results, but with custom DIRs as chosen, and then fill in the information, including this tissue all in one that has all the tissue all in one. Excel causing weird issues again. Yeah, you can switch between. You can copy paste these nodes. Don't forget that you don't always have to recreate everything. Just copy paste and adapt the existing solutions that you have. That's why it's here. There's a node system that you can just front load the mental workload of coming up with a solution, and then you just change it to your needs, copy, duplicate, and change it. And then this way, when you give it to someone, they get jumped here to this view. And I can write a description with this description helper tool here. Okay. Description is like, okay, please provide the inputs. So the inputs directory, setting, structure, must be like condition, and then file name or data set. And set the outputs directory where outputs shall be written run the export results compartment to write all results. You can formulate it, and it will appear here as a description that then everyone can read who opens your project. You can also add images into that one with illustrations. Don't overload it with images, but you can add images in there as well. Then you will encounter projects that are organized like that. As then tomorrow, when Sultan shows you his projects, they are very much organized like that. That they are using a lot heavily this in this directory system, where because we like to keep these projects reusable for different kinds of purposes, easy to adapt to new images. And it's just easier if you have standardized everything, even if it's a bit additional work in the beginning. And even if it's a bit hard to learn this correct formatting here of this file paths, at least then when you have it ingrained within you, then you have exactly the full control where everything is written, and you don't have to shift files around anymore afterwards. Just do it directly in the correct format. You can even then, when you are done, you can compress them and put them somewhere where you want. And it's then fully automated. And then if you run it on a new data set, it's already correctly formatted regarding the output structure as well. So let's check what I do here. So this is again explained how you do this in step by step, and how you adapt the existing system towards their using project directories, and with the result corresponding towards it. So you can always go back to these slides if you're getting stuck. They are up, they're online already, and should help you with that. So then I have another topic a topic complex. It's regarding table and annotation processing, which are important to do and to know what is available. You will use different subsets of those systems. It depends on your use cases. So annotation processing, you use so far annotations only to track data. For example, track the condition of the input file, keep it along in the pipeline, and we use the data, for example, for writing the outputs in the correct format. The same with the image name, for example. But the annotations are very, very more powerful. They can do a lot of things for you. For example, you can use also them for making branching pathways. For example, you have a folder with data, but the data is different depending, for example, in number of channels. They need different handling. Okay, then you make a branching path within JIPipe that investigates the annotation that you extracted out of the file name, for example, or out of the image information, and then you can do some conditional processing and later merge the data together when you are done with normalizing them. So far, also, we only use the tables to generate statistics and then just save them out as an Excel file or something. But it's not the only thing you want. You, for example, want one table with everything. Okay, we did this already, which I already showed. You want, for example, summaries in the end. You want plots, although JIPipe splotting system is a bit limited still until we are done with the new one. And you can also use annotations to really control how nodes behave. You can really make adaptive nodes that adapt to information, that change their parameters, for example, change this radius parameter of morphological operation, etc., depending on what comes in. And they are really somehow related to each other in different ways. And that's why I give you a little bit of a library of operations that you may or may not need for something. It really depends on your use case. And that's why I invite you to just check back again in the slides when you are actually using something. My tables are a bit broken here. Okay. For example, you have set edit annotations. This is one of the base nodes that are very useful when you are modifying actually annotations. For example, you annotated your data with information, and then you want to derive a new information from that or extract a specific part. This set edit annotation will do this for you. You can set specific annotations to a specific value, or you can edit them. You can make new annotations based on existing ones with this formula system. It basically goes in row by row, like in a table in Excel. You can filter by annotations. For example, you can tell it, okay, only take this data with where the annotation fulfills these criteria. For example, if there is like an _1 in the end, then it's some other weird different condition. Please don't forward them. They should be handled by something else. Then related to that is like this if-else annotation where you can match by annotation by a rule set, also defined by these expressions. They are so important, they're everywhere. They then have a set of data that matches that and a set of data that doesn't match that. And based on that, you can do conditional processing. So based on that, you can run different pathways to handle the data differently. You can rename them if, for example, deciding now an annotation that should not be important anymore in the default case. So with this hash, you can say, okay, remove the hash in front, rename hash dataset to just dataset. And you can do that with these nodes, or just outright remove an annotation if it's like spurious, you don't need it anymore for a later processing step, and it just would accumulate in your annotation data table space, and then it gets just confused. Example, you can extract information here in this data set. Each of the file names has a specific format, control, underscore, and then like text, and then underscore a number. And you can, for example, can say this one was a condition and repetition of that or sample depends really on your experimental setup. And then this way you can later do some advanced filtering based on that, or keep better track of them, group them differently. Set edit annotation would allow that. And there's again expressions, they are back. You would use it to add data to, you can add basically multiple of these editing instructions, as many as you want into this interface. Let's see if I explained them a bit. Okay, I explained them a bit, don't worry. I explained them bit by bit what they do. And then add them in. And then you can set the expression that calculates the value for the thing that comes in for the row, and then where it will be written, and can also override annotations as well. So this is what I promised. Let's explore what this actually does. So the split string, what it does is it takes the annotation that exists called hashtag dataset, and it splits it by the underscore. For example, for this D15_1, you get then two items out, D15 and 1. And then this at 0 and this misaligned text here, this basically means take it at the index 0. So this is computer programming thing, counting starts at 0, not at 1. There's just a difference. So you take the first item of that one, and then and it would output D15 for that. This it would repeat automatically when you for everything that goes in your pipeline, fully automatically. And then when you would use the add 1, then it would take the second item out of that, and this way we can get the second component and store it into a different annotation later to be reused in some way. But then regarding table processing, there are also similar nodes. There's the one that I showed you earlier, extract ROI statistics. You can give it regions of interest. You can give it a reference image, and there you can basically measure out the ROI equivalent of image J, where you put the ROI manager onto a new image and then click measure. It's the same thing, but then in JIPipe and automated and with as many tables as you want and your memory allows. Then you have apply expression per row. What it will do, you give it a table and it will go row by row through the table and then does the same thing as set edit annotation. Basically, it's you can calculate a new table column or edit existing values for this current row that it's in. For example, you can calculate a new value. For example, you need the logarithm of a value, then you make a new column, log something something, and then in there is a formula, log something something. We'll see some examples later on. Summarize table would then just create summary statistics, mean, average, etc., standard deviation very quickly. This apply expression to columns is basically the big brother of this summarized table. It can do that and a bit more, where you work on column space directly. It's rarely used, but when it's needed, then it's really needed. Merge table rows would then take multiple tables and put them into one table. So you have one big table, and then you have a lot of plotting nodes. They use a bit limited library, but is still sufficient for checking if everything is okay. And then with the kidney data set, I suggest to make one table with everything using the compartments. So I am gonna add, which one was this? Let me check. Okay, statistics like that. Make a new graph compartment, call it statistics. I named it wrong, thanks. And then we're gonna go tissue and glomeruli. Both in again, like with the export results. And then so we have both available again. And then let's maybe make a big summary, big table with the areas of the tissue, because this is one of the results that come out of this system. Currently, we have the tissues like that, where it runs through one, where we have a table like that. It has only one row usually, because some have two. I have to quickly adapt this thing. This is why the area is over 5,000 and it's still small. Let me quickly adapt this. If you see one of these two rows things, let's quickly go to tissue, and here's in fine particles 2D filter. That's maybe have it 10,000 or something. That so it filters it out. I don't know why the 5,000 worked. And then it should also have it in none of the images anymore. Let's check it quickly. Good, good, good. No. Why? It's number 5. Let's check, check, check. This one is over 10,000. It's trolling me. Okay, then 15,000. I want this one here to be proper. So one row, one row, one row. Okay, now it's correct. Let's then make one summary statistics table with everything in there. That maybe only contains the area and not this ROI name and so on. But there are different solutions, and it could differ now from the lecture slides, but let's do it like that. So let's see, we have a lot of rows here, and we can filter out a lot of columns here. We can filter out most of them there. We don't care about that. So let's do some table processing first and remove the table column. And specifically, and there's again, you get a filter expression. This, like, you will never escape this with JIPipe. They're everywhere. It says here expression, it repeats it per column name, and it's called as a variable value. It's somewhere mentioned, probably. And then what this means is you basically fills in for each column a name called value, and then you check it if it's and it should return true if it should be removed, and false if it should not. And we want to remove them if value is not area. So the not equals is with an exclamation mark, equals, as in many programming languages. Let's try it out. I don't know it myself. Okay, good, it worked. Value not equals area, basically. I can put a box there, so I can continue. And then you can confirm it that it's just a table with one column, just the area. It's not very helpful because the information is missing about the data set and condition in there, but we can fix that. But then let's do it one by one. So okay, let's try out this merge table rows, which would be the next step you would think you would do. Merge table rows, if you run it through, then you would expect that it merges the table rows, it says in its name. But when you run it, actually, you don't. You get 7 tables, and they are very unmerged. Why? So let's check in the inputs again. When you have weird things, check in the inputs. And I say you see it successfully used the data set and condition to keep the tables apart. The system is made so it keeps the data apart from each other that should not go together. And then here it's too successful at doing that. And this is a safe default because you never know which information should go together. So JIPipe assumes like the default safe choice for you. So you have to tell it, no, I am setting the grouping method to all into one batch. It's the exact same thing as in the other example where I saved out the Excel file. It's an inputs, and it's the grouping method. So I just shorted the names a bit. And then when we run that one, then you see not only in inputs quickly before it figured it out. We have one table of everything, but it's absolutely useless because we lost the information. And the data and the annotations don't help us either anymore because they all got merged. You see it here on the right hand and the annotations. Because JIPipe was instructed to merge the annotations with it, it has to do something with them. It tends to just merge them all together into one big annotation that covers the whole set, all the conditions that were there. So what we have to do instead now is we have to add in some code or like a note to tell JIPipe, please copy the information regarding the condition, data set, etc. into the table before we merge this, because at this point, after merging, the information is already destroyed. We cannot trace back which row belongs to which image originally. So we're going to do that to make some space. And there are actually different solutions to that one as well. You can go with apply expression per row, or there's one that is the convenient option. And there's a node that is specifically made for that. Is copy, what was it? Copy annotations. It was that one, I think. Annotate table by merged columns? No, other way around. Table and add annotations as columns. So that I have this menu. What this one will do, it will basically just copy the information that is here outside as in form of annotations into the table as columns, and it just repeats the value, so it's safe. And then later we can just merge it. So if I run this, then we still have 7 tables, but each single one has the information copied from JIPipe's managed annotations into the table itself. And then you can do some other processing, like, okay, let's do this actually. And then when we merge it, we have one big table, a long table that has all 7 images with together this data set and condition information plus the area in square pixels as well. Then we can do some other processing, like making it nice. You can rename the columns. You can sort the columns as well. By there are specific operations for that that help you with that. But then, for example, let's do some simple calculation, which you can also do on the annotation space. For example, you want to calculate the area squared or something. So apply expression per row. Then the parameters you want to say, please write into the new column that we make, area squared. And then what it does, it applies an expression for each single row. It receives the column's value as it says here, like it says it by angle bracket, it means a placeholder value. It is the value of the column for the current row. You have to think a bit different. You have access to the area, which we tracked before. And then, for example, square it up. And then it will run the calculation. We have them both, the area and the area squared, which is a high number. And you can put any calculation in there. You can come up with your custom formulas. You can put in basically any mathematical formula. JIPipe comes preloaded with a lot of mathematical functions in this expression language that will help you with applying different formulas. And then you don't even need to go out of JIPipe. So let me somehow make a box. So we make this is empty, and then make the SD column will be area squared. You can name it however, and the value is that one. It's the expression value that it will calculate every time when it goes through each table row. And it's basically how these Excel things work. When you drag it down or apply the formula and keep it in place so it doesn't do some intelligent things. And then this table you can take in and save out somewhere. But I've showed you already how to save things out, so I don't need to repeat that. So let's continue. Showed you all of that. Yes, there's everything went through. There's also a column, a node where you can sort the table columns, so you can define a manual order as well. This I don't need to show, just observe the example, manually configure that. And then, yeah. So there's the same problem that I showed to you. And then we can have a table like that in the end where, okay, I did not add all the additional information to that, because I just showed you the slides. And then we can make plots. There are plotting nodes for that as well that you can use. You basically put, I don't show this now in the live example. I just show you how it's done. For example, a histogram plot, you point a table towards it and tell it on which columns it should make a plot, and then you can set all kinds of settings like the names and the axis labels and limits, etc. This is the standard case where you would use it. For example, histogram plot, tell it I want, okay, this is so quickly done. Histogram plot, don't mix it up with histogram, because there's also histogram plot and histogram. JFreechart histogram plot, and then I want to take the column area, and then it makes a histogram for me. But this is a very basic plot. looks like that. And then you can edit this in this editor. There will be a better plotting system later on. I don't know when it will be finished, but it will be nicer and have interactive and maybe even animated plots. That will be then actually really nice and usable. But this is the plot system that we have since forever. Java-based plot system. So, and then, yeah, we can make them plots. So there are some things that is important with these tables and annotations, because you saw there are a bit related to each other. Working with tables and annotations, they overlap a bit in regarding their relationship. So, and you can actually pull out information from tables, so statistics that you generated, and then move them back into an annotation. For example, if you want to first calculate a filter value, for example, you want the regions of interest with the area above of the median area of all of them, or something else like that. So that you want it back. Example, I have here this glomeruli example. I'm starving a bit of time, so I'm speeding up. You can basically attach information from a table back to data. It's a bit disjointed now. Currently, I don't have the setup for that. And let's switch it. So basically, when you had like the glomeruli rows that come out, which you can export, and you can basically take measurements, for example, from the tissue, and annotate them directly to the row lists. So you're using the annotation system. For example, I can attach the tissue area to the rows there, or like a mean tissue area, etc. It's not that important now, and I don't think we need it for the exercise either. And then you could, for example, attach it like that, and then do whatever additional filtering and so on. Just review the slides when you need it at some point. And then that one, we can also do like, can skip on that. And then the last one is a bit of extra stuff that one of these things that you should know what exists as methods that you can use for working with JIPipe. Anything that works with labels, working with advanced parameters or label processing, what functions are there, and also filament processing. This will not be like super interactive because you don't have the examples for that. So far we have a simple Roy filtering, and usually this fine particles 2D is used. You have a size filter, you have a singularity filter in there, but obviously, you know, this will not be, you will hit very quickly the limit of this basic filtering. You need filtering by other measurements. You need maybe information from annotations that you added in from other processes and so on. And you need then just more. You need the full flexibility to really do your processing correctly. And that's why JIPipe has a lot of Roy processing nodes that help you with a lot of cases. For example, standard case, as I mentioned yesterday, when you have cells that maybe are over the border, you cannot be sure if the size goes like that or it ends here. So you rather want to remove them. So you can use the remove Roy at borders operation. It's very fast. It needs an image as a reference because the Roys don't store images in JIPipe. And then the very powerful one, filter Roy by statistics, so the advanced version of the what find particles provides you. Then there's an outline operation where you can do convex hulls. You can even do a concave hull. So I implemented one of the concave hull algorithms in there where you can do a bit more than what ImageJ provides you there. And then there's extract Roy statistics that you saw already. There are many nodes, and I noted it at some point already, that have optional input. It's a gray text. This means if you don't provide one, it's not bad, but and it will run through, but it will make usually a black image as a reference image in this case. For example, when you extract ROI statistics, but you only care about the area or shape descriptors, you don't need a reference image. It's enough to have the ROIs themselves, but if you want to make measurements like the average value inside each ROI, then you need to, of course, provide a reference image. Otherwise, the value will be 0. It uses a black image as base. And then we have here this advanced glomerular filtering. So before that, we have fine particles 2D with a where we set the circularity manually from 0.7 to 1, and then have maybe a size constraint, the original data. But what you can do with JIPipe's own system that is exclusively in JIPipe is, for example, have filter ROI by statistics, where you again have an expression. These things come back all the time again, but then you have here the full power of expressions to do really custom things. For example, I can say the circularity should be 0.7, and the mean intensity, which doesn't make sense here for these ones at least, maybe must be larger than all the median of all mean intensities. You can, of course, later set the, oh yeah, it makes sense because I provided here a reference image. Okay, there it will work. And in this way, you can easily filter out in a very specific ways. This one I can actually show quickly. Example here, the glomeruli. They look like that by default. Yeah. Okay, it was not updated. And then we have here so many, but then we want to filter out the ones that are really bright. So filter ROI by statistics, ROI by statistics. And then we give the ROI from the fine particles. And then because we use the mean value, we should give a reference value, otherwise it's gonna be 0. So we use the preprocessed one. And then we set the value here to keep the ROIs if the circularity is larger than 0.7, although we have a different value before. And the mean intensity, which comes from image J, you can look all these values up here that are known to the system while you're editing. The mean value should be larger than the median of all the mean values. And how do I know that? You can see here, yes, for example, I have the area, and then I have area all values, and all the things and all dot things. Because it collects basically the image J statistics and then provides you with all the values. So you have then can do this, which is super annoying to do in image J. And then this way you should see that it filters out a lot of them that are not bright. Okay, maybe you cannot see that because I don't have a reference image to show, but you can imagine if I draw this and make a comparison, then you could really see this nicely. So there's then really the power coming in. And then explanation again, circularity, this comes from image J, should be larger than 0.7. The mean intensity of the current ROI that it looks at should be larger than the median of all the mean intensities. And then you could combine them however you want. Just use the expression builder. It will guide you through that. It will show you variables. It shows you the functions and helps you also building the functions together. For example, if I type in here, I search the median function, that will open like the information, what can be added in, and you can type in basically what should go in. If you, yeah. Then advanced parameters, and there's this really, really advanced parameters. There's this custom parameter system. For example, you have a really complicated calculation and node that has a lot of involved things. Each single JIPipe node allows you to make a custom parameter that you can then from outside control. For example, where did I need this once? This was like a filter key, or it was like a physical size restriction, and then I wanted to make it custom, but the people should not always edit the expression themselves. They should access just a simple parameter from outside. For example, I can customize here, make a custom value for the percentile calculations. People can put a custom percentile in that then you can control from outside. Let's quickly show it. You edit it, and then I add a number, one double, for example, call it percentile, and then want to follow along with that is anyway not needed, but then like okay, 70 percentile, and then I can make a custom function where I can use this custom percentile that I set from outside as the vector. I hope it works. And then you can take this custom parameter, go to this project thing, and you can reference it. And then the user of your pipeline can customize it from here, and they don't have to go into the pipeline and hunt it down. This is the reason why the system is there. And this is very useful when you want to publish it, and then you want to say, okay, this is something that the user of your pipeline has to really control themselves, and you don't want to make a fixed value decision on that. But these are all these advanced things that come up. It's exactly what I've shown. The same way global parameters work, define them globally, and then they are accessed also in a different way. The parameter help thing will help you with these. Then you have adaptive parameters. This is also one of those advanced cases where, for example, what is very common is you have here this top hat operation. And here I set the radius to 12, but maybe the pixel size of your image is different per image. So a 12 pixel radius is not good for each image. It should be always freshly calculated based on the physical size of the pixels. And this way you can do it if you basically track the physical size in annotations. You can click always like this little arrow next to the help button of the parameter, where you not only copy and paste them and reset them, that there's like a setting where you can make the parameter adaptive. They turn them into an expression that you absolutely fully can customize and pull all things into it and make crazy calculations. It's very actively used. Actually, I have many pipelines that are meant to adapt themselves to the physical pixel sizes, and there it's very useful to freshly calculate a value. JIPipe will lock this in. Okay, I'm calculating the value based on that into this log that always runs through at the bottom when it does that. That is a very advanced feature. I don't know if Sultan will show any that will use that. I personally use those a lot. And then you have external parameters. This is also one of those advanced uses where you basically allow JIPipe to run parameter sets. So you rerun the algorithm with different parameters and then test them out basically, or just test out different hypotheses on what parameters you want to use. For example, here in this slides, I have these filter array by statistics. I can enable the external parameter slot, which will add then one slot more to the right of everything. And then you have to provide it a so-called parameter set where JIPipe is instructed, please need this node for each parameter set. Then there's like a whole involved set of settings that I will not go through because this is so super advanced and you rarely need it except when you need it, then you really need it. That's why it's in. I can skip through it a bit. And then you can, it will track these parameters also in the annotation set, so you can then compare what are the results, for example, for a different setting or for a different thresholding method. It's extremely flexible. You can basically put any parameter in there and then compare them, make multiple predictions, see, compare, combine, etc. And then, yeah, this one, not label processing. I've shown you a few algorithms, but it's not that important. It's basically the same system as before with Royce, but with labels. There are specific nodes that I showed you earlier, I think, that would make you label processing. That's basically equivalents of Roy processing that more or less work the same. You can visualize them, you can work with them, but hopefully you don't have to work with labels, they're quite slow. And then filament processing, this is like something that I will definitely not show. This is it's a library specifically built for filamentous objects that JIPipe provides you. You can basically build up a graph, a mathematical graph that maps these filamentous objects into it. I'm almost done. And then, for example, turn an object like that into filaments that JIPipe can track inside, and then you can do all kinds of operations on them. For example, you can set a thickness, you can create a backbone of them, you can make simplification operations. Okay, this is all too crazy. And then the interesting stuff I don't show. Okay, there's a simplification. You can make dissolve connections. You can reconnect filaments. You can copy them across dimensions to do all kinds of crazy measurements with them. And but this is all not subject of that because I'm done, I think, with that. And then all the other stuff, let me check through it if we need it. No, it's fine. So I am basically done with the introduction.